Hello, everyone. I'm audible. So, fine, guys. I think I'm audible to every one of you. Let's start with the class. Good afternoon, everyone. Okay. So, let me share my screen. And yesterday, we were talking about a random forest. So, let's try to understand. Yeah. So yesterday we have seen a random forest implementation, and we all have seen that how we can try to print a different kind of trees that random forest is going to build internally. And yes, it is possible to understand, or it is possible to see tree formations done by a random forest internally. And based on that, so maybe we can try to tune it, or maybe we can try to prune all of those decision trees. That's completely fine. So now, again, in today's class, so it will be extension of the same class. And I believe we have already discussed about a KNN classifier, right? So we talked about a KNN algorithm. And what we can do is we can try to extend a same lecture, and then we can try to talk about how we can see an implementation for a KNN. And then we can try to Okay, so fine, guys. I think I'm back again. So I think there was some issue with my network because of that. So I just got disconnected. Sorry for that. Yeah. So hopefully I'm audible and visible to all of you. Okay. So I was trying to talk about an agenda for today. And yes, so in yesterday's class, we were talking about a decision tree, and we were talking about a random forest, and we all have seen that how we can try to build a model, how we can try to visualize a different kind of a decision tree. So whether it's a random forest or whether it's a decision tree, so yes, it is possible to visualize all the trees. And yes, in this way, I will be able to understand algorithm in a better way, right? So in today's class, the agenda is we are going to talk about, first of all, KNN, K nearest neighbor. Then we are going to talk about SVC or SVM, you can say. And then I'm going to talk about a stacking algorithm, because inside a stacking, I'm going to use this KNN as well as SVM algorithm, because stacking is again an ensemble approach, and where you can try to use heterogeneous algorithm. So not just one algorithm, because we have seen in case of an ensemble technique, so we can try to use only one algorithm as a base algorithm, and we can try to create a multiple instances, or we can try to create a multiple estimators for a particular algorithm. But in case of a stacking technique, so we can try to use any kind of a heterogeneous model. So just an approach of like involving a multiple decision maker at a time. So let's try to understand, and let's try to see how we can try to implement KNN. So I believe KNN implementations we have already done. Sorry, KNN theoretical things we have already discussed, right? Manhattan distance, Hamming distances, equivalent distances, all these things we have already discussed. And we have even discussed about property of KNN, that KNN is nothing but it's a lazy learner algorithm. So instead of creating a model or generalized models or generalized pattern of the data, it will always try to store a whole data set. And then we talked about a KD tree or ball tree by which I will be able to optimize it. So this is something that we have discussed in our theoretical section. So let's try to extend same thing again, and let's try to see some sort of an implementation on top of this one. So let me execute so that I will be able to get back my data set. Please change the screen to full view. I think my screen is already in a full view, right? I have not done any kind of a changes from my end. So just wait for a couple of minutes in between, so I will be able to execute this entire things. So Kunal is saying that can we start with a new notebook and different data sets? So don't worry, Kunal. If I'm going to consider different data sets, so again I'll have to go through entire EDA process of this data set, and then standard scaling, and then I'll have to handle a null values, many more things. So my plan for today is I'll try to talk about this all of this algorithm with the same data set, and then I'm going to give you a completely different data set for your a homework. And yes, so at the end of today's class, you all are going to get a homework, a huge one, a big one, big homework from my side. So that is agenda for today's class. I don't know why my system is taking so much of time to execute these things. So So you are not supposed to execute the whole like a notebook. It's completely fine. What you can do is, so you can try to execute just a data set part, and I think we are good. Okay, so it's taking time. Okay, I think if it is not going to work, then I'll consider a new notebook and then I will start doing each and everything in that notebook. It's fine. Okay, fine. So let's use a new notebook. And what I can do is like from here, at least I can try to copy these things, right? So fine. This is the import which we are going to like do over here. And let me interrupt this kernel. Okay. So fine. This is the import that we have done. So a couple of more import we are supposed to do over here. So maybe we can try to import as we are trying to implement k nearest neighbor, right? So from sklearn, we can try to import neighbors, and here you will be able to find out k nearest neighbor algorithm. So inside sklearn, k nearest neighbor classifier and regression, you all will be able to see. So this is completely fine. Now what we can do is, so maybe we can try to load our data. So my data set is nothing but pandas.read csv, and here we can try to use a same data set. Okay, so it's a wine quality that we have taken, right? Fine. Okay. Fine. So this data set is available to us. We can try to take like a different kind of a data set as well, which I'm going to give you as an homework. So data set volume will be too high, as well as number of attributes you are going to see. It's going to be a huge one, right? So this kind of a data set we are going to consider for our homework, and then whatever we have learned, so based on our task, we can try to accomplish it, right? So it's kind of a like a kind of a task which I'm going to give you in today's class is going to be a build a library which will be able to find out a best possible algorithm by itself. So it's not like you are supposed to do an experiment of all of those algorithm one by one. So this is the kind of a task we are going to take in today's class. So I'll just define a task right after this live discussion. So fine, we are able to call all the required things. Maybe I can try to call a standard scalar as well. So from sklearn, we can try to import pre-processing over here. So you will be able to find out a standard scalar. So yes, standard scalar we can try to import. ROC AUC curve is already done. Profile report is fine. Trend split is fine. Grid search CV we are able to import. Tree is not required in this case. Descent classifier is not required in this case. So maybe we can try to remove these two things. It's completely fine. So we can try to remove this one, and yeah, so we are good with the data. So let's suppose I'm going to consider a same data. So whatever data pre-processing that we have done with respect to this data, so similar kind of a data pre-processing you are supposed to do even with respect to this data set. So as we all know, so we were trying to like remove some of the outliers. We were trying to remove some sort of a skewness into this particular data set. So yes, it's the same thing we can try to execute. So here, if you remember, we have done this operation. So where we were trying to remove the skewness, we were trying to like where is the code for that one? Okay, fine. I think we'll have to do it again. Fine. So this is the data set, and let's start building a model based on top of this one. So here we can try to call maybe a directly an algorithm. So maybe I can try to do just a train test split. So train test a split, and then over here we have to pass X value and we have to pass our Y value. So my X value is going to be all of this column and my Y column is going to be a quality column. So if I have to create my X, so X is nothing but data dot drop I can try to call, and here so column is equal to maybe I can try to say data of maybe a quality, so QUALITY quality. So my X will be prepared. So yeah, quality, and Y is nothing but it's a data dot quality. So fine, my Y is already prepared. Then what we can do is, so maybe we can try to call a train and test split. I'm not doing any kind of a EDA with respect to this data. It's completely fine because we know that what is an issue with this data and what kind of a EDA we are supposed to perform. So whether we have to remove outliers based on the quartiles value, or whether we have to do a null value imputations, or whether we have to like do a zero value imputation. So yes, all those things we can try to perform in a easiest possible way. So directly we can try to do a train and test a split over here without wasting our time, and maybe we can try to pass our X and Y and it will be done. So train and test split will be done. I'm not even going to define like what will be a test percentage or what will be a train percentage. By default, what it will do is 75 is to 25. So 75% of the data set it is going to consider for a training purpose, and 25% of the data set it is going to consider for the testing purpose, which is a regular things. We all have done that so many times. And then there will be a 4 outcome. So we can try to store these things into a X train, X underscore test, and then Y underscore train, and then Y underscore test. So here our main idea is to focus on algorithm instead of focusing on the data pre-processing side, because even random state I'm not going to define. So again, that is completely fine. It's not like every time you have to define a random state, right? It's not a trend that you are supposed to follow, because if your random state is not a constant one, in that case data division for you will be different, data division for me will be different. That is the only meaning of a random state. So it's completely fine. If I want, I can define it. If I don't, that is completely fine. So it is going to like a distribute a data set or a split a data set based on any kind of a random selection. So this is again, the above part is a completely common part. So we can try to implement even a standard scaler over here. If this percent of the data set is high, we can try to even use imputations over here. So if there is some null values, we can try to like change some of the zeros value with mean, median, and mode. If there is some sort of inputs I will be able to receive from a business side that yes, this value should not be a zero. So those things are pretty much common. So don't worry about that. And we are not going to focus on that particular part because we have already seen those things, right? So why to waste a time unnecessarily in those things, because this is not a new data set that I have considered over here. Okay, then what we can do is, so maybe we can try to create an object of my KNN. So KNN is equals to KNN classifier we can try to call. So KNN classifier we can try to call over here. Now let's try to understand this algorithm first of all. So what is the parameter which will be available inside this algorithm? So in nearest neighbor is equal to 5 by default. Weight is equals to uniform. Algorithm is equal to auto. Leaf size is equal to 30. There is a p values. Matrix is equal to Minkowski. Matrix parameter is equal to none. Number of jobs is equals to none. So these are the inbuilt parameter which you will be able to find out with respect to KNN or K nearest neighbor or classifiers. So here number of neighbors is equal to 5, which is given to me. And we are supposed to focus more and more on this number of neighbors, because whenever it will try to build a model, or whenever it will try to check with number of neighbors, that okay, so who and how many number of neighbors we are supposed to consider for a particular data set when we are trying to do a prediction. So this particular factor always plays a very, very important role. So we are supposed to know that what will be the ideal value of number of neighbors. By default, it is 5. So maybe what we can do is, so we can try to train one model with a default parameter, and then we can try to search the optimal value for a number of neighbors, because you are supposed to find out a number of neighbors in an optimized way. K, you are supposed to define at any point of a time. Yes, 5 is given to you, but I can't rely on that particular value, which is 5 given to me, because it's my data set. So there is a possibility that my algorithm is going to give me a best possible result, maybe with a number of neighbors is equals to 10, 12, 20, which I don't know as of now. So it's completely fine. We can try to take an inbuilt parameter as of now, and then we can try to fit in our data set. So KNN dot fit, and if I'm going to send our a train data set, so X train and then Y train, if we are going to send, it's completely fine. This is something that I will be able to get. Let's try to check a score of this particular model. So again, model building is not a big deal, but you are supposed to know about the parameter. That's a main task, right? Because anyone can create a model just by writing one line of a code. So X underscore test we can try to pass, and Y underscore test we can try to pass for finding out the score. So score for this particular things, or score for this KNN classifier, is 0.4675, which is pretty bad, right? So this is not at all a good score that we are able to receive from this particular algorithm. So maybe we can try to work on this one, and maybe we can try to improvise a score, so that I will be able to build a better model. And to improvise this particular score, I'm supposed to focus on a parameters which is given inside this algorithm. And the major parameter that you will be able to find out inside this algorithm is number of neighbors. So maybe number of neighbors is different, and I have given 5 over here, which is an inbuilt one, and because of that, it is giving me a very less accuracy, 0.46 or 46.75%, which is not good at all. So let's try to find out one by one these parameters, and then we can again try to implement, we can again try to find out that what will be the score. So we can try to do one thing. So we can try to perform maybe a grid search CV, or maybe we can try to perform a random search CV. So to perform these kind of operations, I'm supposed to find out, or maybe I'm supposed to create a list of the parameter. So here, so PARAM. So let's suppose these are the list of parameters I'm going to prepare, right? So param, and inside this one, maybe I can try to take number of neighbors. So this is the parameter, number of neighbors, and I can try to consider number of neighbors is equals to maybe 3, 5, 7, 9, 12, 13, 15, 17, 21. So these are the possible candidates for a number of neighbors. I don't know which one is going to perform best, or which one is going to be a worst one. So no issue, that's the reason. So we have a grid search CV, so that I will be able to find out a best possible parameter for this particular algorithm. So these are the list of parameters which I have given. And once I will be able to find out a best possible neighbor, again, we can try to test it. So here, let's try to call maybe a grid search CV. So I don't know whether I have done an import or not for grid search CV. No, I believe I have not done a grid search CV import. So first of all, let's try to import a grid search CV over here. So here we can try to call, okay, this import is done. Grid search CV. So grid search CV, we can try to call, and then inside this one, so we can try to pass our data set, we can try to pass our number of parameters or param values of possible candidates, and then we can try to train a model. So here for KNN, we are trying to perform these operations. For this algorithm, we are trying to perform these operations, And here, so we can try to give a parameter grid. So param grid is equals to nothing but param. So param, this is something that we can try to define. So this is a param that we have given over here. Param grid is equals to this one. And then maybe we can try to define a data set when I'm going to fit in a data set inside a grid search CV. So fine, here is an grid search CV algorithm. So grid underscore CV algorithm that we are able to build. Param grid is equals to PRAM. Okay, so this was the variable name, and grid search CV dot fit, and here, so we can try to fit in our data set, our test data set, not test, train we are supposed to fit, and then we can try to fit y underscore train data set, and this is going to give me, or this is going to train a model, so which is going to give me a best possible parameter. So fine, I can try to find out the best possible parameter by using a grid CV dot parameters, so best params, and here number of neighbors turns out to be 21. Last time I was trying to use number of parameters is equal to 5, but yes, after performing this grid search CV operations, I'm able to find out that number of parameters is equals to 20, number of neighbors is equals to 21. Means whenever we are trying to do a classification, we are supposed to check with 21 number of neighbors, and then we are supposed to find out, we are supposed to go ahead with the voting as per your KNN classifier. So fine, I can try to again build this algorithm, and in this time I can try to give number of neighbors is equals to 21, and then we can try to do some sort of a fit operation. So this time x underscore train and y underscore train, if I'm going to give, so fine, it is going to build my model. Now here I can try to check score. So score wise, I can try to pass x test over here and y test in this particular place, and the score is equals to 0.49. So yes, previously I was able to get 46.75 score, and this time I'm able to receive 49% score. So a little bit improvement, yes, I'm able to make. That's completely fine. So I believe this till this point it's fine, right? Yeah. So why I'm getting neighbors is equal to 17. Okay. So if you are getting neighbors different than me, it simply means that your data distribution and my data distribution is different. Just do one thing to sort out this problem. So let's try to take a random state, right? So random state should be same for me as well as for you. So let's suppose if I'm going to take random state is equals to 20, and even you are supposed to consider the random state same. Fine. So if my random state and if your random state is same, in that case, we both will be able to see a similar kind of a result. So I have kept random state is equals to 20 and then try to check. So in this way, yes, even by changing distribution of the data set, so I'm able to improvise an accuracy. So 54% after choosing a best possible neighbor, and my neighbor is even 17. So again, now accuracy becomes 55.5. So without doing any kind of parameter tuning, we were able to receive 51.75% of accuracy. And after selecting this neighbors is equal to 17, which is nothing but it's an outcome of my best parameter out of this grid search CV. So we are able to get accuracy is equals to 55.5%. Now, this is not the only parameter that you will be able to find out inside K nearest neighbor classifier. Neighbors are important. That's completely fine. Neighbors is equal to 17 means, so we are trying to compare all the input data with 17 neighbors. So means we are trying to select a 17 nearest neighbor, and then we are trying to check, okay, so which class is available in those 17 neighbors in majority, and then that will be the class I will be able to see. Right. So here, again, increment is only 3%. So yeah, you can't expect an increment of 10-20%. So if you are receiving an increment of 10-20%, it simply means that there is some problem with your previous approach and the current approach, because it's a data set, right? And every algorithm try to find out the best possible relations. So this is the only accuracy that you can expect. 3% is very huge. So we always try to struggle for 1% or 2%. And when you will participate in a competition, right? So even 0.01% will matters a lot. If you are able to improvise your accuracy, so let's suppose you and your like a colleague are going to participate, and if your colleague is able to get maybe a 0.01% accuracy more than yours accuracy, he will be a winner, right? So this is how it is. So if we are able to increase 3%, it's actually a good one, right? Believe me, it's actually like a very good improvement that we are able to make in case of machine learning. Now, like I told you, so this is not the only parameter, right? We have other parameters as well. So this is not the only parameter. We have other parameter like a weight is equals to uniform, algorithm is equals to auto. So I believe we talked about these things. So what is the meaning of a weight? So by default, it will try to do a calculation. So here, what KNN does is, so it will try to allocate a weightage to each and every data points that you have in a space. So maybe you can try to give a uniform weightage to each and every points, or maybe a distance based weight. So if distance is less, so in that case, weight will be maybe high. If distance is far, so in that case, weightage will be low. So those kind of things you can try to apply and you can try to check. By default, KNN algorithm, K-nearest neighbor algorithm, try to treat all the data set equally. Means weightage of all the data set is going to be equal, and by default a parameter that you are going to find out will be uniform. But yes, you can try to define it, and weights point by the inverse of the distance. Like I told you, if distance is less, weightage will be high. If the distance is more, in that case weightage will be low. So this is something that we have. Again, inside this one, it will be able to use another algorithms for a data arrangement. So like auto. So in case of auto, it is just going to use a nearest neighbor as per our mathematical calculation that we have done. So it can use a ball tree, it can use a KD tree, it can use a brute force algorithm. So these are nothing but it's a way to optimize your entire procedure. So as we all know, let's suppose if we have arranged our data set in a shape of tree. So over there, my complexity of search or complexity to reach out to any points will be less, and I'm not supposed to check with all the data sets. So just to optimize those complexity, we can try to use a ball tree, or we can try to use a KD tree, as we have already discussed in our theoretical section. So here again, we can try to treat these things as a hyperparameter, because I don't know whether auto is going to work fine for me, whether ball tree or whether KD tree is going to work fine for me. I'm not having any idea, because it always try to generalize a data set based on the nature of the data set. So maybe we can try to do a hyperparameter tuning even based out of this one. Now there is something called as a leaf size. So leaf size is associated with your ball tree or a KD tree, because what will be the size of a leaf means how many number of the leaves will be available in a final node. So where you are trying to make a prediction. So similar to your decision tree algorithm. Now here, so if P is nothing but it's a power parameter for a Minkowski matrices, right? So here if P is equals to 1, so in that case we are trying to calculate a Manhattan distance. If P is equals to 2, in that case we are trying to introduce a Euclidean distances. If we are trying to take some other P, so again in that case our distance calculation formula is going to change. So P always defines your distance calculations, means what kind of a distance you are trying to calculate. We talked about a Manhattan, we talked about a Euclidean, we talked about a which one, the third one, Hamming for a categorical data set. right? So we talked about a three kind of a distances. So how I will be able to set all those three kind of a distances? So if we are going to change a value of p, again, this kind of a questions will be asked in your interview, that let's suppose if I have to choose inside a k nearest neighbor, we are doing a calculation, that is fine. A distance based calculation we are trying to establish, but how I will be able to choose a Hamming distances, or maybe Euclidean distances, or maybe a Hamming distances, or maybe a Manhattan distances, how I will be able to change those kind of a things. So here is a things. So here is a parameter which is given to you, which is nothing but it's a Minkowski matrices, which is going to be responsible for selecting your distance formula or a distance approach. So what kind of a distance calculations you are trying to do? By default, p value will be equal to 2. It simply means that we are trying to utilize equivalent distances all the time. But let's suppose if I would like to use maybe a Manhattan distances, and I think we all understand a difference between Euclidean and Manhattan, right, everyone? Yes. I came for the demo. Is there any sessions explanation, explain the assignments given to us for the practice? No. So we just go ahead with the regular classes. Okay, so I believe we all are aware about this particular fact that yes, we can try to control a different kind of a distances based on the different kind of a approach. So here what I will do is, so maybe I can try to keep a p value is equals to 1. It simply means that I'm trying to select a Manhattan distance, right? Okay, now let's try to test it. Again, a little bit of accuracy we are able to improvise. 0.5% of the accuracy we are able to improvise over here. So it's completely fine, right, guys? So are we able to understand all the parameter? Whether it's a number of neighbors, whether it's a distance that we are supposed to select, whether we are supposed to give a weightage to a nearest neighbors, or we are supposed to treat each and every data points equally. So all those parameters I will be able to control, and this part is important. This is the only part which is important. Apart from that, there is nothing where we are supposed to focus. I think we all are aware about number of jobs, right? We have seen this parameter almost in every algorithm. So number of jobs is nothing but it's related to core CPU core utilization, or the way you are trying to process this entire data set, that is related to a number of jobs. By default, it will be -1. It simply means that it can utilize all of your cores. If you would like to control that, maybe if you just want to take a 4 processor or maybe 8 processor, depends upon the number of processor available inside your system, you can try to set those things. So fine, this time what I will do is, so I can try to maybe do a hyperparameter tuning for all the parameters. So for number of neighbors, we are doing a hyperparameter tuning, right? Maybe for some other things, so for algorithm, right? Again, we can try to do an hyperparameter tuning, because I don't know which one is going to work fine for particular data set. So algorithm wise, we have what? So we have again a multiple choice. By default, it will be auto. So we can try to take maybe auto, ball tree, KD tree, or maybe a brute, right? So these things we can try to select, and we can try to choose that, okay, fine. So which one is going to work for me and which one is not going to work for me. So auto, ball tree, KD tree, brute, all those things we have considered. Maybe we can try to use even leaf size. So what should be an ideal leaf size? Because even that is one of the parameter you will be able to find out in case of a tree formation. So by default, leaf size will be equal to 30. So maybe we can try to tune even this parameter, leaf size. So leaf size we can try to consider, and here is a leaf size we can try to give. So maybe 10, maybe 15, maybe 20 we can try to consider, then 25, then 30, 35, 45 we can try to consider, and maybe 50 we can try to consider. So these are the optional parameter that we have given. Now there is another parameter so called as p. So maybe I can try to test it with p1 and 2 both possible. So here I can try to give parameter p, and possible values can be 1 and 2, because I don't know whether Manhattan is going to work fine for me or Euclidean is going to work fine for me. So we can try to finalize it. We can try to find it out of this parameter search. Then weight parameter, right? So by default, it is going to consider a weightage of each and every parameter as uniform. But I don't know. So maybe if I can give a weightage to a nearest distance candidate, it is going to give me a better result. So here, what I can do is, so maybe I can try to use uniform, and we can try to use distance based. So fine, uniform and distance based. This is the parameter we can try to consider. Then what are the other parameter? It's fine. I think we are good with these many parameters. And then we can try to do a grid search. Value error. Okay, P I have written, I think it's a capital letter and it should be a small. Fine. Fine. So what is the best parameter? So let's try to find it out. Is there some rule to define a leaf size or n neighbors or just a random number? See, we are trying to test it with the random number. Any hyperparameter tuning that you are going to see, it always considers a random number, a sequence of the random number. And based out of that, it is going to give you a result, because you don't know which is a best possible parameter, which I can try to utilize with what kind of a data set. So that's the reason. So we are using just a random number. And again, you can try to give a series of a number, maybe 100, 200, it's completely fine. But the problem is, so if you are going to increase a number of parameter or range of the parameter, again, it is going to increase your computational power in terms of doing a grid search CV. Fine. So these are the parameter that we all are able to find out. Algorithm should be auto, leaf size should be 10, number of neighbors should be 21, P we are supposed to use as 1, weights is equals to distance. So this is the best possible parameter that I'm able to find out of the given parameter. Now I can't say that this is the only best possible parameter, right? Because it is trying to find out a best possible parameter based out of the options that I have given over here, right? And I have given a very, very limited option in this particular place. So maybe I can start from this number, and then I can go till 100, 200 possible. This option is a limited one. Maybe for this option, so I can start from maybe 5 to 10, and then I can go till 100 or thousands. P is equals to 1 and 2. So this is the limited option. This is the limited option. But yeah, for this one and this one, so we can try to increase or decrease a range. So it will always try to find out a best possible parameter based out of the given candidates. And these are my candidates which I have given to this algorithm. So fine, once I'm able to find out, or once I'm able to get a best possible parameter, what I can do is I can try to give all of these parameters over here. So according to my parameter search, so 21 should be a number of neighbors, P should be equal to 1, and weightage is equals to our distance, and here number of neighbors, leaf size, we are supposed to keep it as 10 as per our best possible parameter, and algorithm we are supposed to keep it as auto. Execute, execute, execute. Are we able to improvise a result? Yes. So yeah, we all are able to improvise a particular result, and yes, we are able to improvise our final outcome. So if you remember, what was our when we have done this experiment for the very first time, what was our result? What was our score? So I believe it was 45, 46, or 49, right? When we have fixed a random state, then we were able to improvise our accuracy as 51%. And then after finding out a best possible parameter, so we are able to improvise our score as 63. So again, this is completely fine. So we all can try to implement these things. And I think we are able to see a very good score as compared to a previous score. We all are able to improvise it. Again, there is a chances that we can try to improvise even this particular score. I'm not saying that this is not possible. It is possible. Maybe I can try to work on my random state. I can try to work on my train and test split. So as of now, I have done 75 is to 25. So maybe I can try to change a ratio 90 is to 10. There is a possibility that I will be able to improvise. I can try to change a number or value of the random state. As of now, I have taken 20, right? So maybe I can try to consider something else inside my random state. Maybe so I can try to increase this range and I can try to increase this range. And then again, I will be able to improvise an accuracy. So still there is a chance that I will be able to improvise an accuracy, a best possible one. And this is what we do all the time. So we always try to find out a best possible parameter which is going to give me a best possible score or a best possible accuracy in a very simple way. So this is one of the way, or this is one of the approach by which you are supposed to build a model. This is completely fine. But there is something else that you will be able to find out. So here we are trying to like implement grid search CV. And if you will try to check, right? So what is a CV parameter? By default, it will be able to consider, means cross validation parameter that it will be able to consider. So yes, cross validation is nothing but so number of splits of the data set that we are going to make. So by default, it is going to do a 5-fold cross validation. I can try to change even a value of CV, and then it will help me out to find out a best possible parameter. So these are the way by which you will be able to control your complete accuracy at any point of a time. A very simple way by which you will be able to perform these kind of operations. So I think we all are good, right? So anyone who is having any issue, anyone who is facing any kind of a challenges. So let's suppose if I would like to save this model, so I can try to do one thing. So I can try to do like an import pickle, and pickle dot dump. I can try to call pickle dot dump, and then we can try to dump our KNN model, maybe in some sort of a file system, right? So I can try to maybe like open up some file. So file is knn.pkl into a write binary. So yeah, so here I will be able to dump my entire model. So let me just search for pwd, or I can do ls. So here my model name is knn.pickle. So where is my knn.pickles? So here is my knn.pickle. Now, what is the size of this knn.pickle? Yes. So it's a 240. So maybe 240 kb or 240 MB. Okay. Now, so let's try to check what is the size of our data set, right? So size of this one is fine, but let's try to check what is the size of our data set. So what is the data set that we have considered? This one is a data set that we have considered. And here it is. So size of my data set is this one, and size of my model is this one. So can I say that after using a different parameter, right, we are able to build a model? Or let's suppose if I'm going to change a parameter, let's suppose I'm going to do this operations. So I'm not going to use any parameter. Let's suppose I'm not going to use any parameter. I'm going to name it as KNN1, and then KNN1 dot fit without using any parameter. And let's suppose if I'm going to save this model, KNN1 model, so pickle dot dump, I can try to call pickle dot dump, and here, so I would like to dump my KNN1. KNN I have already saved. Open one particular file, maybe knn1.pkl, and then we can try to write it down, right? And then try to check just for the comparison, right? So we have knn1 and we have knn.pickle. So can I say that when I'm trying to change a parameter, size of my model is going to change. Yes, and I believe we all know a reason, right? So when we were talking about a KNN in a theoretical section, so we were talking about KNN algorithms as a lazy learner algorithm. This is what we have discussed. And at that point of a time, so again, if I'll do a same thing, let's suppose with my linear regression or with my logistic regression. So number of attributes I have not changed, whether it's a KNN or whether it's a KNN1. Number of attributes is same, means number of x that we have, x1, x2, x3 is same. There is no changes in a number of parameter. Again, algorithms I have not changed, right? It's a base algorithm is KNN. Again, inside that I'm changing a parameter, right? So as I told you that here in case of a KNN, it's a lazy learner algorithm. So instead of storing a model or a kind of a object which is going to generalize your entire data set, so it always try to store what? A data itself, right? So sometime it is trying to store a complete data set in a form of tree, sometime in a form of ball tree, KD tree, right? So in this way it is trying to hold my complete data set. So if I'm going to change my parameter, structure of a tree is going to change, so the size of the tree is going to change, split of the data is going to change, and so my model size is going to change. And if you will try to compare model size of KNN with respect to a model size that we are going to build in linear regression or logistics, it is very, very high, right? So this is what happens in case of a KNN, and that's the reason so it's called as lazy learner algorithm. So it always depends upon our data set. Let's suppose if I'm going to double the data set. So can I say that again it is going to change? Because my tree structure will change, right? So finally it is trying to store what? My original data. So if I'm going to increase a size of the data, right? Again, this will change. If I'm going to change a parameter, again, this is going to change, right? So this is something happens in case of a KNN algorithm. So KNN model. Simple. It is storing the data and parameter, right? Yes, it is storing a data majorly. So it is trying to arrange a data based out of your parameter. So it is using a parameter just to make an arrangement of the data set. That's it. So we can also make use of KWArgs to give a best parameter rather than manually mentioning. So yes, we are actually using KWArgs. So if you will just observe this one. So can I say that this is a KWArgs parameter? Key and value, right? So instead of writing those KWArgs inside your git search CV parameter directly, so we are trying to pass a dictionary. It's same thing. It's a KWArgs we are trying to pass, right? As per the signature of the this particular function, this particular method. So if the size of the data set is huge, then the model size will also increase. So yes, that is true. That's the reason. So it's called as lazy learner algorithm. And that's the reason it's not advisable to use your KNN algorithm in case of a huge data set. You can try to test it because your train as well as test complexity is going to increase. Majorly, it is going to increase your test complexity, right? So again and again, it will have to do a calculation. So here number of neighbors is equal to 21. So every time with 21 neighbors, it is going to like a check, and then it is supposed to go for a voting. So it's a reason. That's a reason. So it's advisable to all of us that never use KNN if I have a huge amount of a data set. Fine. Once we are able to see a physical file, so this is a same file we can try to deploy. Yes. So I believe if I have this pickle file, I have this physical file, physical model file. This is the same file we are supposed to deploy. So we are supposed to send all those inputs as per the like a number of attributes that we have, x1, x2, x3, and it will be able to give me a result. So if I have to do a prediction, so maybe I can try to call knn.predict, right? So predict, and then I can try to pass my data set. So I can try to pass my x test, and this is the predictions that I'm able to see over here. And yeah, I can try to compare. or if I have to do a prediction for an individual data set, even that is possible. So X test, and let me take out some of the individual data set out of this one. So maybe X test we have, and I can try to extract any one data set that we have over here. So X test, and ILOC of 0. So this is the data set that we will be able to see, right? And we can try to even pass this data set. And this is the prediction that we will be able to receive. So whether it's an individual prediction or whether it's a bulk prediction, so yes, I can say it. So now if I'll ask you to write an API by using a Flask, so where you are supposed to send this data set through a Postman, or maybe through a web page or through HTML pages. So I think we all will be able to send those data set to this model, and then whatever prediction it is giving you, so you are supposed to showcase these things, or maybe you are supposed to store this prediction into a databases. So I believe we all will be able to do that, right, everyone? Yeah, okay. So how is the score calculated for KNN? If you could repeat once. See, a score at any point of a time is nothing but it's your accuracy. Now accuracy is not a best possible parameter, because accuracy we always try to calculate based out of the confusion matrices, where we are considering true positive, true negative, false positive, false negative, all those things, right? Accuracy is, yes, one of the parameter, but based on the context and based on the business use cases, we are supposed to consider precision recall F1 score. That is our actual parameter. So somewhere we are supposed to use a precision, somewhere we are supposed to use a recall, somewhere we can try to use F1 score, but score by default is giving you an accuracy. That's it. So again, score is not a reliable factor, but here, if I would like to see a sentiment of these things, so we can try to use sentiment of my training and test accuracy. In that case, score is fine. We can try to use it. That's it. Okay. Now here, let's try to understand a different algorithm called as support vector machine. So I believe we talked about a support vector machine, right? Theoretically. So what is a support vector machine, how it is going to work, how it is going to behave, how it is going to give you a final outcome. And support vector machine always try to draw a hyperplane, right? And there will be a support vector. So nearest support vector, it will try to find out, it will create a margins in between. So it should always try to draw a hyperplane in such a way that a distance from hyperplane to a margin will be maximum in case of a classification. So this is something that we have discussed in terms of a support vector machine. Support vector regressor you can try to use, or support vector classifier you can try to use. Plus, we have also discussed one thing in support vector machine called as kernel trick. So anyone who remembers kernel trick? Yes. So where we are supposed to use a kernel trick, by the way? Kernel trick is for a non-linear data, okay, prediction into a higher dimension. Incorrect, change the dimension of the data set, that is correct. But where we are supposed to use, fine, we are changing a dimension from 2D to 3D, 3D to 4D, ND to N plus 1D, that is completely fine. But where we are supposed to use this approach, where we are supposed to use a kernel trick, when we have more than 3 dimension, again incorrect. When we can't draw a separation, yeah, that's correct. So see, kernel trick is nothing but it's a technique, or it's an approach by which it will be able to change a dimension of the data. So maybe it is not possible to draw a line in a original form of the data, original dimension of the data. But if we are going to increase a dimension, so for sure, I will be able to get in a space where I will be able to put up an hyperplane. And this is where a kernel tricks comes into a picture. So there are different kind of kernel functions which is available. So radial bias function is one of the most famous and popular functions that we generally use in case of a kernel tricks. So because we are trying to draw an hyperplane. So if I will not be able to get a clarity to draw an hyperplane, so even if I will be able to draw an hyperplane, it is not going to increase my accuracy, or it is not going to build a best possible model. This is where kernel tricks comes into picture. So people always ask a question in an interview from a kernel trick, that why you are using kernel trick. They may give you a situation, they may give you a scenario. So let's suppose if I'll give you a scenario, right? If I'll give you a scenario that, okay, fine, so we have this data and we have, let's suppose, this kind of a data. Do we need a kernel trick over here? I believe we don't, right? So in this case, we don't need a kernel trick, because yes, it is possible to create a separation. It is possible to draw an hyperplane and a margin line in this particular case with respect to this data set. But at the same point of a time, if I'm going to give you a data, right? So let's suppose this is a data set which is given to you, and this is a data set which is given to you, right? And if I'm asking you to try to build a model which will be able to do a classification between red and black. Yes. So can I say that in original state of the data, it is not possible to draw a plane in between. So let's suppose this is a two-dimensional data. So in this case, it is not possible to draw a hyperplane. You will not be able to separate a data set at all. So what I will do, so maybe I can try to change a dimension of the data. So I can try to derive a third dimension of the data. Z is equal to maybe x plus y, or maybe x square plus y square, x square plus y square under root. So we can try to use any custom functions as well, or maybe some of the predefined functions. So RBF is nothing but it's a predefined one of the function. That's it, which helps you out to find out the third dimension. It is not doing anything extra. So kernel trick is not like an alien thing for all of us. It's a very simple thing. It helps us to increase a dimension of the data set so that I will be able to create a separations in between. So here, let's suppose this is a data set. This is the data points which is given to me. And if so this is a 2D data set which is given to me. Let's suppose if I have to increase a dimension of this data, so maybe what I can do is I can try to use Z is equals to x square plus y square, Z is equals to x plus y, Z is equal to under root of x square plus y square, Z is equal to log of xy. There are so many ways by which I will be able to derive a third dimension. It just depends upon my base mathematical equation, right? By which I will be able to derive a third dimension or maybe a Z dimension. So it's completely fine. This is where kernel tricks comes into picture. Now what kernel tricks will do? So let's suppose if I'm going to define a third dimension, so maybe I can try to represent my data set in this way. Same data set, maybe I will be able to represent in this way, right? So yes, now I'm able to get some sort of a space where I can draw a hyperplane, which can create a separations in between a data, and it will be able to create a margin line, which will pass through a support vectors. This is something called a support vector in case of a support vector machine, right? So this is something that we can do. So this is where things comes into a picture, and from SVM, people will always ask a question. So if they are talking about SVM, right? So they will always try to focus more and more on a kernel trick. So they would like to know that whether you are aware about this kernel tricks or not, and in which cases, what kind of a kernel tricks you are trying to use, what and all things you have solved, why it is required, what is the advantages, disadvantages. So they will always ask a question around this particular part from a support vector machine, apart from your core algorithm, right? That what is the meaning of hyperplane, what is the meaning of support vectors, what is something called as margin line. So apart from these things, they will try to ask only one like a questions from a kernel tricks. So fine, let's try to build a model with the help of support vector machine. It is just a recap of the support vector machine that we have already discussed. So we have a data set, we have a same data we are going to use. So let's suppose I have a data set over here. I can try to use a same thing. We have 6 number of classes, so it's a multi-class classifications. that we are trying to understand. Maybe I can try to like import, or maybe I can try to call this one a support vector machine. So here I can try to do one thing. So from sklearn, so sklearn dot svm, yeah, from support vector. So try to import sv, so try to import svc. So svc is for support vector classifier, svr for support vector regression. So here we are trying to import this svc support vector classifier because we have a classification data set as of now, and then we can try to build a model. So maybe svc is equals to, svc is an object of my svc, right? svc, and then we can try to fit in our data set directly. As of now, I'm not doing any parameter search over here, and we can try to fit in our data set. So x train, and then same old distribution I'm using. So x train and y train over here, I can try to use, and I'm able to build a model. That's completely fine, which can be done in one single line. SVC dot score, we can try to calculate, and here when we are trying to calculate a score, we can try to pass x test and we can try to pass y test over here. So x test and y test we can try to give in this particular place. Now, what is the accuracy that we are able to receive? It's a 50% accuracy that we are able to receive as of now, without doing any kind of a hyperparameter tuning. So far, so forth. I'm just trying to use a default hyperparameter over here, right? Just a default hyperparameter I'm trying to use in this particular place. Now, what I can do is, there are so many hyperparameter. C is equals to 1, kernel. This is something called as kernel tricks. Kernel is equals to RBF. RBF full form is nothing but radial bias function, which can be used for defining your higher dimension all the time, right? Degree is equals to 3, gamma is equal to scale, coefficient is equal to 0.0, shrinking factor is equal to true, probability is equal to false. Yeah, I can try to make it true. So there are so many parameters you will be able to find out in case of SVC, support vector classifier. And these are the parameter you are supposed to understand. That will be your responsibility to understand this parameter, and then you are supposed to tune your algorithm in that way. So fine, let's try to understand all of these parameters one by one. What is the meaning of C is equals to 1, then kernel, then degree, and all those things. So here, C is nothing but it's kind of a relation parameter, right? So kernel is nothing but linear, polynomial, RBF, sigmoid, or pre-computed. So I believe last time I have shown you RBF equation. So what you can do is you can just try to go to a Wikipedia. So RBF Wikipedia. So here you will be able to get a clear function or a clear mathematical equation. So what RBF does, right? What radial bias function does. So equations you will be able to find out in this particular place. So here it is just trying to define a third parameter, or maybe it is just trying to derive one more state for any kind of a input data that you are going to give as an input. That's it. Nothing else it is trying to define by itself. So just a common functions that you can try to use, radial bias functions. That's it. So it's completely fine. We can try to use RBF, we can try to use a polynomial, we can try to use a linear functions to define. Linear means x plus y kind of a function, so x plus y is equals to z. Polynomial is nothing but maybe x square plus y square is equal to z square. Sigmoid, so I think we all are aware about it, 1 by 1 plus e to the power minus of x, right? Pre-computed, so again we can try to use any other custom mathematical function. So yeah, you can try to test your third dimension, maybe with linear, maybe with polynomial, maybe with RBF, maybe with sigmoid, maybe with the pre-computed one. By default, so it is going to use radial bias function, because it's proven that when you are using a RBF and a kind of a dimension which it is going to derive for you based out of the RBF equation. So again, just a mathematical equation. You are going to put a data and then you will be able to get an output, and that output is going to be considered as a third dimension. Means it is going to elevate or it is going to increase that particular dimension. This is the only thing which it is doing, nothing much, right? Which is called as kernel trick. So when you are using a kernel trick word, so there may be a linear kernel trick, there may be a polynomial kernel trick, there will be a RBF based kernel trick, there will be a sigmoid kernel trick, or you can try to give your own kernel trick in a pre-computed one, right? So this is fine. Now degree. So degree of polynomial kernel function. So what is, so when we are going to define this polynomial function, so what will be a degree? So ignored by all other kernels. So if you are going to set degree is equals to 2, and if you are using poly as a kernel, so if degree is equal to 2 means z square is equal to x square plus y square. Or let's suppose I have x1, x2, x3, x5, x10. So x1 square, x2 square, x3 square, and so on is going to be a next dimension. It is going to create. This is something happens. So if you are going to use poly as a parameter, only in that case degree will be applicable. Let's suppose if I have used RBF, and if I'm going to set degree is equals to 4, it is not going to consider at all. This is the meaning of a degree parameter. So is this two things clear to all of you? What is the meaning of kernel inside SVM and what is the meaning of degree? Yes. Okay, fine. Now, so there is a parameter called as gamma. So gamma is like a, again, scale and auto. So kernel coefficient for RBF, polynomial, and sigmoid. See, so if you will go and check your radial bias function, so you will be able to find out a revision parameter or a constant parameter called as gamma over here, or lambda, right? So this is just required for doing a calculation. That's it. It's a part of your equation. So you can try to control that gamma, means you are actually controlling your RBF. This is what it means. So here gamma is nothing but, so like the kernel coefficient for RBF, polynomial, and sigmoid. So everywhere, whenever you are using these functions, so except a linear, so RBF, polynomial, or sigmoid, it's a constant, just a constant, right? Which is associated with all of these equations. So you can try to control. And if you are controlling gamma, it simply means that a third dimension, which it is going to create, you will be able to control that. So it's not, so why, see, everything on all the parameters over here will be associated with the kernel itself. Why? Why we are just focusing on kernels more and more? The reason behind this one is kernel is responsible for creating a next dimension, n plus 1th dimension of the data set. So it's not like we are supposed to create a very huge differences, right? A very huge differences between all the data set, or a very low differences between all the data set, because very huge distance and very low distance between two different classes is again going to create a problem in terms of doing a separations, in terms of doing a classification, and it is going to generate a false positive result. There is a chances, there is a possibility. So just to eliminate those things inside a SVM itself, you have a different multiple parameters that, okay, so you can try to control and you can try to keep on changing these values, and based out of that you will be able to tune the complete hyperparameter plus a kernel trick equation that you are using, whether it's a polynomial, whether it's a RBF, whether it's a linear, or whether it's a sigmoid. So you will be able to control even these functions, which is responsible for creating the next dimension or next space for the data set. So that is something which is important, right? So everything is associated with what? Your kernel function. Okay. Now here, so coefficient. So again, this is associated with the kernel function. Like I told you, majority of the parameter inside a support vector machine is associated with the kernel, and that is the reason. So everyone just focuses on the kernel trait, right? That what do you understand by degree? What do you understand by gamma? What do you understand by the coefficient? So independent term in the kernel function, so which is called as like a coefficient, default is 0.0. So it is only significant in terms of if you are going to choose kernel is equal to poly or kernel is equal to sigmoid. Again, kernel specific parameters which is given to you. Shrinking. So again, so shrinking inside the SVM. So if we are trying to like shrink the data set, if it is going to be true or it is going to be false. Probability. So generally we don't use a probability in case of a SVM, right? But yes, so if you are looking for that, so you can try to control that as well from here. Tolerance for stopping the criterion, and then a check size. So kernel check size. So what will be the kernel cache size? So what is the kernel cache size that you are going to create? means when kernel is going to create a third dimension, so what would be the max to max size it is going to consider, right? That is something called as a cat size. Class weights, so whatever classes that we have, right? So each and every classes that you are going to consider, maybe 5 class, 6 class, 10 class, in terms of a classification, in terms of prediction parameter, right? So you can try to define a weightage of all the classes, or maybe you can try to treat all the classes with the same weight. So this is what it has been defined, and this is the formula which is given to you to consider a weightage of the class. Now verbose is nothing but it is going to give you a log. So I believe verbose is not a new parameter for us, right? So we have already seen this verbose parameter multiple times, right? Maximum number of iterations. So how many times you would like to send the data set, right? Inside the solver, inside the algorithm, inside the kernels, how many times you would like to send the data set? That is something called as number of iterations. Decision function shape. So you can try to use 1 versus 1, or maybe you can try to use 1 versus the rest. This is something that you will be able to find out, right? Again, break ties. So again, this is like a true or false kind of a function, so which will help you out to break a tie between two classes. Let's suppose I have done the prediction. So true and false is the class. Now for true, I'm getting prediction probability is equal to 0.5. And even for false, I'm getting prediction probability is equals to 0.5. So in that case, what we are supposed to do, right? So how we will be able to break a tie? So if we are going to keep it as a true, it will be able to break a tie by using a specific function over here. Random state. So how it is going to distribute a data set in a subsample. So these are the parameter that we have inside a support vector machine. And I think we are able to understand the meaning of each and every parameter, that what parameter is going to define what kind of a, or what parameter is going to help you out in what kind of a, like a model building approach. That is completely fine. So again, if I have to find out a best possible parameter, what we can do is we can try to implement a grid search CV, and based on the grid search CV, so I can try to perform these kind of operations. So grid search, random search, these kind of things is completely fine, or k-fold cross validations. So here, let's try to do this. Let's try to find out grid search CV, and inside a grid search CV, so we are supposed to pass a parameter, right? So maybe I can try to create a variable called as param. I can try to define a different possible parameters. So starting from the very first one here. So which kernel I'm supposed to choose, and I'm confused, right? So I don't know what kind of a kernel I'm supposed to choose over here. So what I can do is I can try to pass a list of all the kernels. So let's suppose RBF, let's suppose linear, let's suppose a sigmoid function. So all possible kernels I can try to pass over here. All possible kernels I can try to pass over here. Now inside a grid search CV, so let's suppose we are going to create an object. So SVM underscore grid. This is an object which we can try to create. And here inside a grid search CV, so we can try to give SVC, right? And then we can try to give maybe a parameter grid is equals to PARM, the same variable that we have created. And then we can try to test it. We are just supposed to find out that which kernel trick is going to work fine for me. Now SVM underscore grid dot fit I can try to call, and then I can try to pass maybe X train and then Y train. Invalid syntaxes. Okay, so where is a mistake? Kernel is equals to, fine, this is the mistake, rectified, done. So fine, let's try to understand what is the best possible kernel trick function that we can try to use, and then we can try to alter a value of gamma or maybe value of a degree based on the kernel that we are going to select. When we use break ties is equals to true. So whenever we have, there is a chances that, okay, in most of the input data set, it is going to give me a prediction 0.5, 0. It's equal prediction, right? For a two classes, maybe in one versus one versus rest. So in that case, we can try to use this. So svm dot grid, and then we can try to find out the best possible parameter. So for this one, our best possible parameter is a linear. So whenever we are trying, so best possible kernel we are supposed to use with respect to this particular data set is equals to linear, right? So fine, no issue. We can try to use it. So kernel is equals to linear. We can try to use. So here I can try to create again SV1, which is the object of SVC, and here, so kernel is equals to linear. We can try to use, and SVC dot fit and x underscore train, comma y underscore train, right? And then I can try to find out SVC dot score. So SVC dot score, and yeah, so we can try to pass x test, and we can try to pass our y test, and my work is done. No improvements. 0.5, same as before. Okay, sorry, it should be SVC1, right? SVC1. Yes, we are able to get some improvement. So 0.5 to 0.6 approximately. Yes. So yes, these things are working. So we all are able to see that, yeah, things is working. Although I have not even checked the nature of the data set. So if I'll try to plot the data set, maybe I'll be able to find out the nature of the data set in a better way, right? I can do something else. But yeah, I'm just trying to take a random data set, and then I'm trying to pass this data set inside the algorithm, and we are able to achieve this much of accuracy, which is pretty much good. So is this things fine to everyone? Yeah. So if it is like a linear, so maybe we can try to use a parameter which is associated to a linear kernel, right? So there are so many kernels, so we can't use degree because degree is associated with what? Just a polynomial, right? Again, we can't try to do anything with respect to a gamma because gamma is associated with RBF polynomial or maybe a sigmoid. So we are not supposed to use anything. Maybe I can try to use a poly over here. There is a possibility, poly, and then we can try to check the accuracy. So poly is giving me 0.49, even like a lesser than an RBF. Yes. So even lesser than the RBF, this is something that we are able to see over here. So here, let's suppose I can try to tweak these things with respect to different values. So maybe I can try to give a value of C, right? So what is the value of C, by the way? Anyone? We have C, right? No. So what is the meaning of this one? What is the meaning of this C value? Yes. So basically it's been used to regularize the entire algorithm. So it is going to control a changes that we are going to make each and every time, adjustment in a hyperplane that we are going to make each and every time. So this is what it is going to control, because adjustment we are trying to do with respect to an error function. So for sure there will be an error function, right? So error function will try to adjust, or error function based on the error function. So we will try to adjust a parameter which is responsible for plotting up complete hyperplane, right? So here with the help of maybe a relation, I will be able to handle it, right? So is it like the learning rate? No, it's like your wrist lasso and elastic net that we have already discussed in case of your linear regression, right? So we were trying to use a regression parameter. So it's just like that. Okay. So here maybe we can try to give a range of, or range of the value of C, right? So because I don't know what kind of what value of C is going to work for me. So maybe I can try to give a range of the value. So I can try to give 0.1, I can try to give a 0.4, I can try to give maybe a 0.6, I can try to give 1, I can try to give 2, I can try to give 3. These are the points which I have given. Maybe I can try to give some higher points as well, 100, 200, and then 500 possible. So this is just a regression parameter. So regression parameter is always inversely proportional to the changes that it is going to make. Then maybe gamma, right? So what is gamma, by the way? What is gamma? This one? Yeah. So I think we talked about a gamma, right? So again, this is nothing but a constant which is applicable for RBF polynomial and for the sigmoid, not for any other things, right? So this is responsible for RBF polynomial and just for the sigmoid. So if it is going to select RBF, then only it will try to find out the gamma parameter. Otherwise, it will not even try to touch my gamma parameter. Same will go with the degree. So if it is polynomial, only in that case, it is going to touch my degree parameter. Otherwise, there is no meaning of giving a degree parameter. So it's completely fine. Maybe we can try to give a range of the gamma, right? Which is again a regression parameter, right? So here, by default, a value of the gamma that it will be able to consider is 1 by number of feature into variance of x. Yes. So if auto, if you are going to use gamma is equals to auto, so in that case, it is going to consider gamma is equals to, gamma value is equals to 1 by number of features. How many number of features do we have? Yes, how many number of features do we have? Number of features means what? Number of x values. Yes, so I believe 11, right? 11 to 12 is the total number of the data set. Again, I don't remember. I'll have to like a count. So maybe I can try to count it. X train. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 12 is a total number of attributes, total number of the data set size. So it's a 11 number of a feature that we have. So here, if we are going to calculate a gamma, so by default, if it is in an auto mode, so it will try to, if I'm going to like take a default value of a gamma, right? So if I'm going to take a default value of the gamma, which is auto, so in that case, it is going to consider value of gamma is equals to 1 by number of feature. But if I'm going to consider maybe a scale, so in that case, this is the formula which it is going to utilize. And again, this gamma is nothing but just one of the parameter, a constant associated with our function to control a third dimension. That's it, right? Okay, so to control the third dimension, so here we can try to like give a range of the gamma parameter. So let's suppose I can give a range of gamma parameter. It should be very, very small. So 0.001, because it's 1 by number of features, maybe 0.1. Maybe I can try to give 0.4, then 0.004, right? So maybe this kind of a numbers which I can try to assign for this one, 0.003. So these are the gamma values that I can try to assign. Apart from that, so I can try to assign the rest of the values. That's completely fine. Yeah. So here, maybe I can try to give a verbose so that I will be able to understand verbose is equals to 3. So I will be able to understand the internal mechanism, what it is trying to do like internally. So I will be able to understand that particular part. So see, this is what happens in case of a verbose. Yeah. So I have kept verbose is equal to what? 3, right? So it is trying to print all the logs. So here you will be able to see that what has happened internally. So when I'm trying to call svm grid.fit, I'm trying to send my data set, right? So what kind of validations it is trying to do, or what kind of a job it is trying to execute, what is a score it is able to fetch or it is able to get. So here you will be able to find out that when C is equals to 0.1, right? C is equals to 0.1, gamma is equal to 0.001, kernel is equals to linear. When it has taken this combination, and this combination, at that point of a time, the score is equals to 60%, right? When C is equals to 0.1, this one, and again C is equals to 0.1 gamma linear score is equals to this much. So in a next iteration, so again this one, C is equals to 1 gamma kernel. Now C is equal to 0.1 gamma kernel is equal to polynomial. This is the score. So this is what internally it does. So I'm just trying to like print the internal things. So what will happen, what system does when it will try to perform these kind of operations, and everything you will be able to see, all the log informations you will be able to see. So I'm just trying to set verbose is equal to 3 because verbose is responsible for printing a log. Yes. Okay. So again, from here itself, you will be able to find out a best possible parameter just from here. So which one should be a best possible parameter? So this is what it gives when I call like a best parameter. So it will always try to give you a parameter out of this particular selection. So still it is trying to execute, and it is trying to do a computation. So is it fine for everyone? So are we able to understand each and everything? Yes. Please explain gamma. Okay. See, just try to understand this RBF function. I'm just looking for a mathematical equation, so where I can show you, because in radial bias function, so here they have represented two factors. If you will try to check a final radial bias function, so one is called as like a lambda, and this is the function of this entire things. So this is what we are trying to control. Okay, so just wait as this parameter, number of parameter is used, so it is going to take some time. In the above equation, they have taken gamma is equals to 1. Yeah, so just it's a part of your radial bias function itself, so that mathematical formula. So it's a constant that we can try to change. Value error, it should not be a square kernel matrices getting above error while fitting. So what is the data set you are using? Because it should not give you, it should be a square kernel matrix. No, I don't think so. You are making some sort of a mistake. Mine is not a square matrix, but still it is like a working fine for me. Remove pre-computed from your parameter space. Okay, so I believe you have used this pre-computed as well, right? Over here, I have used linear polynomial, RBF, and sigmoid. So you must have used pre-computed. So yes, if you are using a pre-computed, then it will give you that error. Otherwise, it's fine. That's the reason. So I have not considered pre-computed. I have just selected a linear polynomial, RBF, and sigmoid. So fine, just wait. This is kind of you can say an operations which always takes time, plus entire process. So CPU is fine, GPU is 10%, CPU is 10%. Both is fine. My laptop is saying I cannot handle this. Yeah. Kunal is saying that his laptop is not able to handle. So parameter tuning, generally we do over a high performance computation system. So because see, this is not only a range of parameters. We have just taken a subset of the range of parameters. If you are looking for a best possible parameter, you have to give a big range, right? And for sure, your local system will not be able to n job is equal to -1 will make it faster. Anyhow, I have not set the n jobs, right? So by default, it is -1. So if it is -1, so by default, it is utilizing all of my processors. So it will actually make your system slow, not fast, because it is utilizing all of your resources. While doing a project for the multi-problem, I am facing this computation issue, need to sit even for 15-20 minutes. Yeah, that's true. That is like something which is very, very common with respect to our system. So that's the reason. So like across the enterprise, so we are not using our local system. So we always use a cloud-based computation system, and over there we perform. So what we do is, so we try to prepare a skeleton of the code inside our local system, and when we have to do actual training, we always do actual training on HPC, high performance computation system. Lots of money for cloud. Yeah, so for sure, the company that you are going to join, right, they have a capability to spend that much. So for them, it's nothing. For individuals, yeah, it's like so guys, you can do one thing. You can come to Iron office, right? And in our new innovation lab that we are setting up as of now, which will be ready by December, I believe. So there will be a high performance computation system available in a local mode itself. So you can come and you can experiment. So even 10 people, 20 people can sit in one system, but that system will never be, that system is not going to be a slow. So you can use HPC in our lab, and you can do as much experiment as you want. So today I'm reading O'Reilly books. There is a question: what to do if GPU time run out while training your CNN? In that case, decrease your batch size, because the reason behind running out your GPU is that it is trying to do. There is a different like a gradient descent which it does internally. There is something called as batch, there is something called as stochastic, there is something called as a mini batch. So in case of a stochastic, what happens is it will send one data, do a error calculation, and then do a backward propagation. So it is not supposed to remember anything. But let's suppose if I'm using a batch, my batch size is very, very high. Let's suppose a number of iteration is again very, very high. So it will keep on doing a calculation for each and every batch unless it is not going to finish the entire data set, right? And it will keep on storing an outcome of each and every batch, outcome error of each and every batch, because over there, error will be a summation of all the batches, right? So it needs a huge amount of memory to store your total or to calculate your total error. That is the reason. So it's always advisable to decrease your batch sizes and try to use maybe a mini batch instead of using a batch or maybe a stochastic. So that is a solution. So in deep learning, so whenever you will do your like a object detection problem, when you will solve object tracking problem, when you will solve object segmentation problem, when you will solve in your deep learning classes, in your computer vision classes, you all are going to face this issue, all of you. So all of you are going to get a mom issue. So issue. So out of memory, double OM. So it's like, it's very, very common. All of you are going to face this kind of issue, Kunal. What happens to use a collab? So see, collab is giving you V100, right? So if you are going to use a collab pro, it is going to give you V100. If you are using maybe a free version, so I believe sometime back I have checked, maybe 6 months, 5 months back, so they were giving P6000. So again, P6000 is one of the GPU, right? V100 is one of the GPU. So it's like if you have a huge amount of data, a batch size is high, batch is as a better method or gradient function that you are using. So again, it will take time. Things, deep learning, machine learning training always takes time. It's not like just click and then it will be done. No, not at all. I think about more ways to handle this, as they have asked for 5 ways. Yeah, so one of the ways is like handling your batches. Second way is reducing your number of the data, right? That you are trying to give if you have a limited computation power. Third thing is, so maybe you can try to increase a number of iteration by decreasing a batch, right? Fifth thing is, maybe you can try to change a dimension of the data. If you are using a 3D data, which is nothing but RGB channel, if you are going to use image data, but not a grayscale data, RGB. So again, in that case, your batch is going to increase. So instead of using that, try to use a grayscale data. So I think you are able to get your 5 solution. TensorFlow has TF data generator. Yeah, that is here. That is there since a very, very long time. But again, it is not going to help you out much to optimize a large scale data. No, I think you are not able to understand the meaning of TF data generator. Meaning is something different. Suvan. It gives early stopping, which means it doesn't have much to learn, if I'm not wrong. Yeah, this is the meaning of early stopping. So you're not supposed to burn your instances, your computational power, if your error rate is not going to change. Let's suppose my error is constant. It simply means that I'm not able to learn something, but still I'm trying to like ascend my data set again and again and again. So it's better to use early stopping. So in case of early stopping, by the time it will feel that no, there is no changes, I'm able to observe, stop it. No need to test with all the permutation combination. That is something called as early stopping. Will the concept of threading helps us here? Not at all. Not even a single %. So here, concept of distribution system helps you out, not a concept of threading. There is a difference between threading and a distribution. You said about the GPU setting. Does it applicable here? Yes, it is applicable. We can try to run. How to convert these code into a PyCharm? Is this a question? I'll give you a task, and next time 100 people are going to show you a solution of the task in a PyCharm. This is what we have done, right? I'm like, do we have to ask this question? How to convert? So PyCharm is something specific. It's just an ID where we can write a code, right? Even in notebook, Notepad++, I can write a code. That's completely fine. I read about OOB score in O really. Can you please explain? Okay, I'll explain. So once I'll be using this OOB score, I'll explain. C is the short margin parameter. True. Can multiprocessing solve the problem of multi-processing solve the problem of multi-training? I mean, like how these two things are correlated. I'm just trying to understand that part. Can we parallelly train a different model for the same data? Parallelly, I think, right? Parallelly train a different model for the same data set? Yes, we can do that for sure. Kunal is saying out of bag. Yeah, that is a full form of OOB. I'm aware about it. So out of bag. It's basically a part of your decision tree. So okay, I think I should terminate this part. Okay, fine. So best parameter I will be able to find out, and then once this things will be done, I can try to check my accuracy, and then once I will be able to check my accuracy, again my work will be done, and I will be able to perform a prediction. That's not an issue at all, right? Okay, so let's do one thing. So SVC we are able to understand, right? Let's try to understand SVR. So let's try to like understand SVR. So let's take one simple small data set so that I will be able to understand, or I will be able to explain SVR over here. So I'll be using just a flat data set for all of you, and then based out of that, so I can try to do some sort of maybe prediction or something, right? so that I can show you how regression works in this case. So which data set I can consider? Maybe a same old data set I can try to consider. Okay, so SVR, let's try to understand that. So I'm going to load one data, pandas dot, just to show you a use case, not to like, because we all know about support vector machine, right? So support vector machine can be used for regression as well as for classification. And even decision tree can be used for regression classification. KNN can be used for regression and classification. So whenever person is going to ask you that what in all regression algorithm you know, right? Always name all of these algorithms. Yeah, but don't say logistic. Logistic is not for regression, just for classification. So never say logistic. But yeah, support vector machine, inside that SVC, SVR for regression, C for classification. So maybe I can load this data admission prediction.csv. Here we are supposed to predict chance of admit. I believe we all have this data, right? This is the very first data set we have taken. So we can try to use this data set. We are not going to do like any kind of a null value validations or maybe some sort of a replacement or anything. It's like, it's just like we can try to use a data set as it is. Yeah. So we can try to like use this data set as it is, and we can try to fit, and then we can try to predict what is the chance of admission. So this is a data set. This is the data frame that we have. Maybe we can try to create X value. So our X is nothing but, so data frame dot maybe drop, drop, and I think we are supposed to drop this serial number. Yeah, serial number is fine. So we are supposed to drop a serial number and chance of admit. So fine, I'll just copy the serial number. So drop what? So drop basically serial number and chance of admit, so that I can try to create my X. I can create my X. So execute key error. So serial number not found in axis. So I have to change my axis over here. It is trying to find out these things in a row. Maybe I can try to set axis is equals to 1, which is a column axis. So fine, this is now, that's good. Okay, so this is the data set, which is X. Now, if I have to create my Y, so data frame dot, so chance of admit. Data frame dot chance of admit. Chance of admit. So fine, I'm able to create Y, I'm able to create X. Here, my problem statement is to find out the prediction. So this is a regression problem. I'm supposed to find out the number, that what would be the chance of admission. No issue. So I can try to find out. Maybe I can try to do a train and test split, although it's not required. So it's fine. I can try to do these things without doing a train and test split. So train test X, maybe a random underscore state. We can try to set 30, let's suppose, and split size or test size I can try to create over here, and that can be maybe 20:80. So 20 test size, and yeah, so 80 train size here. So X underscore train comma X underscore test comma Y underscore train comma Y underscore test is equals to execute. So train test is split done from sklearn. So sklearn dot svm import svr. Import is done. Now create an object of svr. Create an object of svr over here. So object of svr is svr. Now what we can do is svr dot fit and X underscore train comma Y underscore train. Execute. Okay, so here, why you are not doing EDA or any other operation? So why I should repeat a same thing again and again, right? to kill your 1 hour when we know what we can do with the EDA, right? So guys, is it required to do like a null value validations, a standard scalar and everything every time? No, right? It's fine. We are trying to learn an algorithm first of all. So there was a time when we were learning just a EDA. There was a time when we were trying to learn just a theory. Now there is a time when we are trying to see just an implementation. Then there will be a time when we will combine each and everything. So why to waste a time? It's like I think we all are mature enough to understand those things, right? So when we are able to understand, so no need to repeat it. Okay, so SVR is fine, and value error input contain NN infinity or value is too large for a D type float 64 X train Y train fit. Yeah, for EDA, Pandas profiling is the best. So we can just try to call profile report inside that, pass your data frame. You will be able to get one single huge report for each and every attributes that you have. So out of that, you will be able to see all the observations. Once you are able to get all the observations, then just have to act accordingly. Nothing to write, no need to write even a single line of a code. We have optimized our most of the EDA process in just one line. Okay, so I have some issue with respect to a data set. So yeah, there is an issue with respect to a data set because there is some null values which we have inside a data frame. So data frame dot is NA. So false, 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 anywhere true. So maybe I can try to do a summation of it. Okay, so in GRE score, TOEFL score, and university rating, right? So we have some missing values. That was a problem. That's the reason. So input contains NaN. This is the this is the final this is the error I'm able to get. So yes, in that case, what I'm supposed to do? So maybe I'm supposed to do some sort of an imputation, right? I'm supposed to remove this null values. Otherwise, I will not be able to do any kind of a implementation with respect to my data set. So GRE, TOEFL, university, fine, no issue. I'll just do an imputation with respect to a mean values or maybe a mode values. Anything is fine. So DF of a GRE score, DF of a GRE score is equals to DF of GRE score dot fill NA, right? DF of GRE score dot mean. So pretty much simple, and GRE score will be handled. So now we don't have any null value inside GRE score. Now let's handle this TOEFL. So DF of this TOEFL is you can write a code even in single line. So you can write one for loop, identify which and all column values. This result is not equal to 0, and then optimize it. So even in, so extract a column name and then do a computation one by one. That is possible in one single for loop. Fill NA DF of this TOEFL score, DF of this TOEFL score dot mean, and yes, so bracket close. Okay, so it's fine. Now university rating. Rating dot fill NA, and here, so we can try to take DF of university rating dot mean and done. So fine, my data frame is now yeah, there is no null values now. So I can try to re-execute a same thing. So I'll try to recreate my X and my Y and my algorithm. So now it is working. SVR.fit X train and Y train. I'm trying to fit inside my support vector regressor. And yes, I'm able to get an answer. So with respect to a support vector regression, again, I'm just using a vanilla version, a vanilla flavor of SVR. I have not used or I have not done any kind of a hyperparameter tuning as of now. There are so many hyperparameter approximately same as your classification, right? Kernel, we all understands. Degree, we all understands. Gamma, we all understands. Coefficient, total, tolerance, everything we already understand, right? So I'm just showing you like, yes, there is something called as SVR which exists, right? So that you will be able to recall it as and when it is required. It's not like otherwise what happens is you don't know what, like there is something called as SVR even exists. So just to show you that my motto is not to teach you SVR, because we already know SVM and we have done experiment with all of our parameters in a SVC. So here what we can do is maybe if I have to check an accuracy of this model, right? So anyone who can tell me what we are supposed to use? This is a regression. So what we are supposed to use? Can I say I can try to use maybe a R square? Yes. MSC, it's a mean squared error. So that will help me to tune a parameter, right? Or change a value of my hyperplane. This is where like MSC comes into a picture. That's fine. So here, if I have to find out maybe an accuracy, so what I can do is, so I can try to maybe call R square, R2 score. So maybe I can try to write from scikit-learn, right, dot matrices, and we can try to import R square, right? So R2 score we can try to recall. Fine. Now, so R2 score, if we are able to recall over here, then we can try to pass maybe a Y underscore test. Yes. So Y underscore test, which is the expected one, and what will be a predicted one? So the model that we have created, that dot predict, that is going to give me the predicted one. So here I can try to pass X underscore test. So what is my accuracy for this regression? So this is my accuracy for a regression. This is something that I will be able to see. If I have to do a prediction, so yes, I can do a predictions even over here. So let's suppose someone has given me that GRE score, TOEFL score, all those things is this much, then what will be the chance of admission? If someone is asking me to do a prediction. So no issue, I can try to take any of this data. So let's suppose this is the data frame, right? This is the data frame. So I can try to take maybe any of this data. So LOC of 0, I can try to take, and then I can try to pass this data set inside my model that I have built just now. So SVR dot predict. So value error, why? ILOC except should be 9 equal to, okay, yeah. So it's like I have just used the original data frame and I have just removed a serial number and a chance of admit, which is here. So I'm supposed to select something from my X. So instead of using DF, I can try to use X. So what is the chance of admission? It's a 89.25, right? This is what X says. And yeah, so if I would like to like know what is a value of Y0, Y0. So my expectation was 0.92 and my prediction is 0.89. So yes, it's pretty good. We are close to our expected result. So is it fine? Okay, so the Sneeth is asking me that can we use a score over here? So X underscore test, the way we were using for a classification problem. So can we use this one? So, okay, someone is saying no, someone is saying yes. So any idea? So why so if we are saying yes, can we use score over here? Okay, so people are saying yes, people are saying no, right? Okay, fine. Let me show you one thing. SVC. This is the object that we have created, I believe. And here, so we were trying to pass maybe our X test and Y test kind of a data. Now, are you able to see some differences? Just do one thing. Just try to observe. We are using a score function over here. We are using a score function over here, right? Just check a definition. So just remember, just have a look of this definition and just have a look of this definition. Is it same? No, right? It simply means that yes, we can use a score is a common function which is available for classification and which is available for regression. But the way it's been implemented is not same. So for regression, right? So what we try to find out R score, R square, right? So can I say that in case of a regression, it is trying to call this function which is trying to calculate R square? Yes, R square. And in case of a classification, it is trying to call my accuracy out of the confusion matrices. Yes, so function name is same, but implementation is not same inside the function. So same function name is available for this one regression as well as for classification, but body of this function is different for regression and for classification. So calculation is different for regression and classification. A very simple one. So never get confused, right? That you are using a same score function. Some people always gets confused that we are using a same thing in classification, same thing in regression. And we never like have a habit to look into that definition, that what is the implementation of a score function that we are using with respect to a regression and the score function that we are using with respect to a classification. So please always try to have a look when you are trying to call something. Yeah, so hope this idea is clear to all of you, right? Okay, so this is just a SVR that we have seen. We can try to like store this model, and then we can try to like productionize this model, which is again pretty much possible. Now the next algorithm that we may try to explore over here. So as we are able to talk about a KNN, we are able to talk about the support vector machine. Maybe we can try to talk about a stacking, right? Because I'm going to use stacking inside your, or I'm going to use SVM and KNN inside your stacking. So fine, let's try to understand what is stacking, and then let's try to understand how stacking helps us to build a better model. What kind of a theory which comes into a picture when we are talking about a stacking, right? So stacking is nothing but it's one of the ensemble technique, and I believe we all understand some meaning of ensemble technique. So ensemble technique is a kind of a technique where we try to involve not just one estimator. So instead of involving just one estimator, we try to involve a multiple estimator. So boosting is a part of ensemble technique, bagging is a part of ensemble technique, stacking is a part of ensemble technique, because in all of these places we are trying to involve a multiple estimators, a multiple stakeholders which will be able to give me a prediction. So stacking is one of the approach which is defined inside a ensemble technique. So how stacking is different from your boosting or maybe bagging. So if I'll talk about boosting or bagging over here, you always try to use a similar kind of a estimator, or you always try to use a similar kind of a base algorithm or base model. So let's suppose if I'm trying to create a bag, so I'll try to create a bag of maybe just a decision tree, bag of maybe just a support vector classifier, bag of maybe just a KNN algorithm I will try to create. But let's suppose I'm trying to create a container, and inside that container I don't want to use just combination of like a one algorithm or 10 instance or n number of instance of only one algorithm. I would like to like use instances of a multiple algorithm. So is it possible in case of a bagging? No, it is not possible, right? It is not possible at all, and it is not going to allow you. But if we are going to use stacking concept, in case of a stacking, yes, it is possible. You can try to use a heterogeneous model, a different models, right? As many number of models as you want, and you will be able to build a model based out of this stacking approach, right? And that is the reason. So we have stacking over here. So fine, guys, let's try to understand original idea behind a, so this is just an idea, that's it. This is how it is called as ensemble technique, because it is trying to involve a multiple models but in different way. Yes. Okay, so let's do one thing. So let's try to do a implementation of maybe this stacking. So what we can do is maybe we can try to uh, call all the algorithms that we are going to use. Yeah, so let's do an implementation. Okay, so here is stacking. Fine. So here we are going to study stacking. So let me import all the required library again. Pandas as PD. Maybe I can try to import NumPy as NP. We can try to import from sklearn. I can try to import KNN neighbors. Import KNN neighbors, capital K classifier. We can try to import from sklearn. We can try to import maybe a SVM class and import basically SVC over here. We can try to import sklearn. Oh, maybe sklearn. So we can try to import maybe a sklearn model selection. So import train test split. And maybe we can try to import a random forest or model. Sklearn dot ensemble and import random forest classifier. Fine. So these are the imports that we are supposed to do as of now. Very simple. So I'm not going to show you a data pre-processing. So I'm going to use a data set directly. So my whole idea is over here is to show you stacking. So how stacking is possible and what happens internally inside the stacking. So is it fine to all of you? Yes. Okay, fine. So let's start. So diabetes data set, let's suppose pandas dot read CSV and oh, KNN, right? So data set that I've used, I can try to use same data set. Okay, so this is the data set that we are going to use, and this is my data, same old familiar data. We have 6 number of classes, we have these many things over here, right? I can try to use any other data set, that's fine. So X is nothing but data dot drop, and what we are supposed to drop, quality. So data dot drop columns is equal to quality column, right? And Y is nothing but so data dot quality. Okay, so X and Y is created. Now we can try to call maybe a train and test split X comma Y random underscore state is equals to maybe 30 I can give, and test split split, maybe I can try to make it as 0.10 or 1.5, let's suppose. It's fine. 1.5, and it is going to give me x underscore train, x underscore like a test over here, y underscore train, and y underscore test in this particular place. Okay, type error, invalid parameter, test split. PST. Okay, so test size, right? Size JD size. Fine, this is done. So training and test split is done, right? Now what we will do, so maybe I can try to call one of the algorithm, right? I'm talking about stacking. So first of all, as I will progress, so you will be able to understand what is the actual meaning of a stacking. So just wait for that and go step by step always, right? This is the best way to understand a stacking part. Otherwise, you will see some sort of a confusion in between. And I think within half an hour, so we will end up discussing this stacking approach in a easiest possible way. So just do these things with me. So are we good? Are we able to do it together? I think I haven't done anything so far. I'm just trying to call the data set and standard approach. That's it. Yeah, fine. So just try to do these things along with me. All of you will be able to understand stacking for sure. It's just a procedure of like arrangements of a training. That's it. Nothing much. Fine. So fine. Let's do it together then. So maybe what I will do is, so I have done a split of the data. Fine. So here I will draw a diagram. We have a data set. We have a data set. Now here, so I'm trying to divide my data set in two sectors, train and test. So this is what I have done, X train, X test, Y train, Y test. So this is something that I have done so far. Now what I will do, so once I'm able to split this data, let's try to pass this training data, means this set of the data set which I have in my left hand side as per this diagram, right? So let's try to pass this data set into any algorithm. So let's suppose I'm going to use K nearest neighbor classifier. It's a classification problem I'm trying to solve. Same, you can do these things for regression. There is no issue. So here classification problem I'm trying to solve. So I'm going to call any classifier. It can be KNN, it can be SVM, it can be logistics, it can be whatever you want. So here I'm just trying to call my KNN classifier. I'm not going to focus on the hyperparameter, that we know how to do it. So in a later stage, we can do it. So KNN classifier I'm going to call. And then here I'm going to fit my data. So we are just trying to learn like what happens inside stacking. What is the approach to build a stack? So X underscore a train we can try to pass, and then Y underscore train we can try to pass. Fine. Now it will try to build a model. So yes, it will be able to build a model. Maybe I can try to give a verbose over here. That is going to help, or else that's fine. So yeah, K-nearest neighbor classifier. So this is the model that it will be able to build on this training data set. And then maybe I can try to find out, or I can try to use another model, right? So where I can try to pass a same data, and then I can try to build a model. And let's try to check an accuracy. So what is the accuracy of KNN? So what is the score of KNN? So score of KNN is nothing but, so X test I can try to pass, comma, Y underscore test I can try to pass. So accuracy is equals to 50%. I'm not worried about accuracy. So my tendency is not to improvise accuracy at all. My tendency is to establish a stacking approach. Then in later stage, I will try to improvise my accuracy. Fine. Now here, then we can do one thing. So we can try to build another model. So one model designed, another model. So let's suppose I'm going to build as SVC, support vector classifier. So SVC I can try to use, and then here I can try to pass a data. So SVC dot fit. Now inside that, so I can try to pass X train, comma, Y underscore train. I can try to pass. So done. Now if I would like to calculate a score of this one, so SCORE score of this one. So what we can do is we can try to pass x underscore test maybe. So score, so x underscore test and then y underscore test, and I will be able to calculate a score. That's fine. So now I'll draw again one diagram. So there was a training data. Now out of this training data, what I'm trying to do is, so I'm trying to build two models. This one is KNN and this one is SVC. Both of these models are using the same data. KNN is using the same data and this one is using the same data. So out of the same data, I have built two models over here. Now what is next? What is next which we are supposed to do over here? So we have built two models, KNN and SVC, right? And always keep this diagram in your mind when you are trying to understand stacking. What I will do is, so I will try to do a prediction from KNN. So KNN dot predict, right? So KNN dot predict. So what I'm supposed to give for a prediction? So I'm supposed to give basically some sort of a data set. If I'm looking for a prediction, right? I'm supposed to give some sort of a data set for a prediction. So what data set I'm actually supposed to give for a prediction? So let's try to understand that particular part. So here, when we have done a data division, so here when we are trying to do our data division, so X train, Y train, X test and Y test, right? So this data division we have done based on the original data. We had an original data set, and based on that, so we have done this train and a test split. And then we are trying to send some of the data set into SKNN and some of the data set we are supposed to send inside SVC. But before that, what we were supposed to do is, so we are not supposed to pass X and Y. So this is how approach is different. Generally what we do, so we try to pass XY, which is the original data, and we try to create X train, X test, Y train, Y test. That is fine with respect to any other approach. But when we are talking about this stacking approach, so we are supposed to do a two level of a data division in general two level of data division. So what kind of a data division which we are supposed to do? So we are supposed to divide our original data set into first one division, and then we are supposed to take a subset of that data as a training and a testing data. So this is a little bit confusing, and this is the only point you have to clarify to understand a stacking. So how data division happens in case of a stacking. So let's try to do it and you will be able to understand. So train test split, right? X comma Y you are supposed to pass, then test underscore size that you are supposed to define over here. Let's suppose it's a 50%, and then random underscore state that you are going to keep is equals to, let's suppose 30, something like that. Now this is going to give you 4 subset as a return, right? So you can try to keep it as, so you can try to treat these things as train and then validation underscore train and then test and then validation underscore test. This is the name which I have given. So here train and test, validation train, validation test. So 50% of the data, just like this one, right? So 50% of the data will be available here. So just focus on this statement. So can I say that 50% of the data set will be available here and 50% of the data set will be available inside the validation? As per this statement, can I say that 50% of the data set will be available here and 50% of the data set will be available here, right? So training data and a validation of the training data. This is where I'm trying to divide the data set. So this data set division, so we are trying to do, that is completely fine, but not in this way directly. So we are going to change our approach a little bit. So we have our data over here and just try to compare with this one, right hand side. So we have a data and now we are trying to divide our data into train and basically a validation data set. So train and validation. This is my train, this is my validation data set. Just like X train, X test, right? So just a name. Now out of this data, so whatever training data that we have, right? So whatever training data that we have, that we are trying to use, so this is my X and this is my Y for training. So whatever training data that we have, we are supposed to send that data set over here. Train and test. So we are supposed to send this data. So can I say that if I have 100 number of records, 50 records will be available over here? If I have in total 100 records, so over here, how many records will be there? Only 50 records. I will be able to find out over here. That's completely fine. Only 50 records I will be able to see over here. Now, out of this 50 records, right? So let's suppose I'm going to keep maybe 20 or 25 over here, right? So out of this 50 records, let's suppose if I'm going to allocate 20%, right? So in that case, 10 record will go to a test and 40 records will go to train. Fine. So in our regular approach, we try to create train and test data set in this way. But in case of a stacking, we have changed our approach of dividing a data. So first of all, we are dividing a data into train and validation. Just follow your left hand side diagram, and the original one is a right hand side diagram. The previous approach was right hand side diagram. Then out of this training data, right? So out of this training data set that we have chosen, so then we are trying to create our X train and then X test, right? So X train we are trying to create and X test we are trying to create. So let's suppose we have 100 record over here. So over here there will be 50 record, 50 record. Over here 40 and 10 record we will be able to see. This is the hierarchy so far, so forth. Now, so when we are trying to train our model, so now we are trying to train our model. So generally we try to train our model on top of the original split. But here, again, name wise, I have not changed the name, but yeah, so X train and Y train. So here, can we say that we are sending a 40 record over here, 40 record over here out of 100? Yeah. So can we say that here we are sending 40 record? If my total number of record is equal to 100, so we are sending 40 record over here and a 40 record over here. Yes, everyone agree? Okay. So here we have a 40 record. So we are trying to train it. We are able to test it. We are able to test it because this is the model that we have created. This is the model that we have created out of this data, and we are using this data for the testing purpose. That is completely fine. Now, what about this 50 record? Why we are trying to keep this 50 record? And what I will do with this rest of the 50 record, which I have divided, but I have never used so far, so forth, because this is something which I'm using for training and this is something I've used for testing. I'm able to get the score. That's fine, right? But what about this validation data, which I have already created? What I'm going to do with that? So once I will be able to build a model, right? Once I will be able to build a model. So here I'm trying to build what? A KNN and SVC. This is a two models which I'm able to build based out of this 40 number of records that we already have. So once I will be able to build this particular model, then I'm going to pass this validation data set over here. So what is a validation data set? So this is the data set which I'm going to pass over here. For what purpose? So for doing a prediction. So can I say that this is my X data, X50 record, and this is my Y50 record, rest of the 50 record available over here. Guys, are you able to understand this hierarchy data distribution? Yes. Okay. So this is my X50 record. So this is my X50 record and this is my Y50 record. So X and Y is available to me. Now here in terms of prediction, I'm going to pass this data. So what is the variable name? So validation underscore train. This is the X value, which I'm going to pass, right? And then prediction. So prediction out of KNN, let's suppose we are able to see. Now here we can try to do a prediction. Prediction using SVC. So SVC dot predict, and we are going to pass what data? A validation record. This 50 record we are going to pass over here. So validation train data we are going to pass. So fine, we are able to do a prediction. Based out of this 50-50 records, validation train is not defined. Where is not defined? I have not executed. Why? Okay. So validation train, we will be able to see and we will be able to get it. Right? Okay, fine. So validation train. So I'm able to get a prediction out of this validation data set. So can I say that this validation, it is going to give me for a 50 record? Yes, this validation, it is going to give me for a 50 record. Okay. Now, can I say that again, I'm trying to find out a validation. I'm trying to find out validation out of this one. So I'm trying to find out a validation out of this two algorithm. So KNN and SVC I have built. I'm trying to do a prediction over here, but I'm using this data in both the places. This data I'm trying to use in both the places. Now, whatever prediction result I will be able to get, Y hat KNN, let's suppose, and Y hat SVC. So whatever prediction result I will be able to get, what I'm going to do is, so maybe I'm going to treat that as an input. Because let's suppose if I have to train a next model. So stacking is very simple. We have model number 1, we have model number 2. Now model number 2 and model number 1 will give an input into model number 3. So this is called as stacking. But what input it will give? So what kind of an input model number 1 and model number 2 will give for a model number 3? So here with the help of KNN, I'm able to do a prediction, right? So this model number 1, which is KNN, it is giving me prediction. It is also giving me prediction. I will try to combine these two prediction, and then I will try to send this prediction as an X over here in case of a stacking. So it's a little bit different approach. So this prediction plus this prediction, I'm going to combine, and then I'm going to send these things inside the model number 3. Now you may ask me a question that, okay, you are saying that this will be X1 and this will be X2, means prediction. This one is going to be my X1. This is going to be my X2, a feature. Then what will be the label? Because we are using a supervised machine learning problem. We are solving a supervised machine learning problem. So can I say that I have used validation X data to do this prediction X1 and Y1, X1 and X2, right? To do this prediction and to make these things as a, originally it's a nothing but it's a Y, means outcome. But I'm going to treat these things as a feature, because for this model, it will be Y hat. For this model, it will be Y hat. But for this model number 3, it is going to be a X1, X2. Yes. So here, if this is going to be your feature, then what is going to be a label? So label is nothing but we have a validation data set. Inside our validation data set, we have X, we have used it. We have Y as well. So that will be a label. Now, why we are using it, we'll try to conclude. We'll try to conclude what is the advantages I will be able to get. But first of all, let's try to understand the approach. So here we are doing a prediction. Then what I will do is, so let's suppose if I'm going to show you a prediction KNN. So this is a prediction from KNN. Then I'm going to show you prediction from SVC, right? Prediction from SVC. So this is the prediction from SVC. We are able to get it, right? Then what we are trying to do is we are trying to call numpy dot column stack, right? Because we have to build a feature, and these two are just a array, numpy array that we have. So we are going to call a column wise stacking, and then we can try to send prediction KNN, comma, prediction SVC over here. Now, this is a kind of a data set you all will be able to see, or you all will be able to find out. A complete stacked data means in parallel, we are trying to combine this data. We are trying to create two columns. In one column, you will be able to find out this data set, and in another column, you will be able to find out this data set. Is it making sense? I'm just trying to prepare an input for this third model, M3. I think till this point, it's fine, right? Model M1, M2. There is no issue with that. We are trying to pass same data inside M1, same data inside M2. And then we are trying to keep another data set separately. We are trying to keep a 50% of the data set for my next level of the model, right? So whatever outcome M1 and M2 is going to give me, that I'm going to consider as an input to the next M3. and it's a supervised machine learning issue, a supervised machine learning problem. So we must be having y as well. So for whatever input we have done this prediction, right? So we have a respective y, we have this validation test, right, which can behave as a y for me. Okay, so this is going to be, right, so this is going to be, let's suppose I'm going to write it down for input for third model, input 3, right, input 3, and your output 3 is going to be what? So validation, this is the variable name I have kept, right, validation test. Okay, so this will be my validation test. So I have an input, I have a output. So this is what I'm expecting as an output, and this is something which I'm going to give as an input over here. So this is something which I'm going to give as an input, and this is my output. You can try to see it even in form of data frame, so it will show you a better result. So maybe pandas dot data frame I can try to call. So this is going to be my input. Is it fine? These two columns, this is the column that we have created, right, with the help of column stack. Yeah, so this is the column that we have created, and this is something that we are trying to use as an input. Input for what? So input for my next model M3. And what is my y? So my y is nothing but, my expected y is nothing but, this is the output validation test which I have prepared. Again, size of that data set is equals to same, right, same as this one, because from like a same data set I'm trying to find out this derivations. Now let's suppose my next model, right, so my next model is going to be, right, so my next model is going to be, my M3 is going to be some model called as random forest or maybe a decision tree. So yes, I can try to use any of these things. I can try to use maybe a random forest, I can try to use maybe a decision tree, and that is completely fine for me. So what I can do over here is, so maybe I can try to call a random forest. I believe I have done the import. So random forest classifier, RF, and then RF dot fit, and what I'm going to fit. So I'm going to fit like a input 3, comma, output, and this is going to build my random forest classifier, the third one. So this is how stacking is associated with each other. So what I have done, if you will try to summarize, so I have taken a data, I have done a split of the data. So over here we have a 50%, over here we have a 50%. I have used this 50% of the data, and again I'm trying to do a split. So maybe into 40, sorry, so like yeah, let's suppose count of the data set is 100, so don't consider it percentage, otherwise you will again get confused. Let's suppose 100 data, so 50 is here, 50 is here, out of 50, 40 is here, 10 is here. Now based out of this particular data set, I have trained 2 models, right? So one of my model name is KNN, and one of my model is SVM or SVC, right? It's a part of SVM itself. Now I'm using this data. So I'm using this data inside this model, to do a prediction. Then what I'm trying to do, so after doing a prediction, so I'm trying to combine. So let's suppose this will give a prediction, this will give a prediction for this data, this input data. So once it will be able to give me a prediction, what I will do over here is that I will try to combine, and this combination I will try to send into a model number 3, which is a random forest for me. So this is a stacking approach. This is something that we are trying to utilize. This 10% of the data set we are trying to keep for the model validation. So just to check what will be the accuracy of the model, because this 10% is not used yet for a training purposes. This 10% is nowhere involved in terms of doing a training. Is it fine? Yes. So someone was saying that 10% data set of X trade is still unused. No, it's not unused, because you have to keep a data set which is not doing up any kind of a participation in terms of a training purpose, right? That is that 10% data set which I can use for doing a prediction. Can we take 50%? See, percentage you can define based on your like a intuition. That is something called as hyperparameter. So it's not like I have used 50%, so you have to use 50%. No, not like that. It's just an approach, just to explain you. I have taken 50-50 so that your calculation will be easy. You can try to use 60-40, whatever you want, 30-40, 60-40, right? So here, so finally, this algorithm will try to learn. This algorithm will try to learn, and then this algorithm will be able to give you the prediction. So here, right? So here we are trying to build a model which is nothing but a random forest, which is taking an input, which is a combination of an output, combination of an output of KNN and your SVC. So KNN and SVC, which is using the same kind of a data set for you, right? So this is something that you are trying to like do over here. Now here, so if you are going to like do some sort of a prediction, or maybe if you have to like check what is the accuracy or what is like a score that I will be having. So how I will be able to check an accuracy, or how I will be able to check a score over here. Let's try to understand again that particular part. So can I say that this is fine? I'm able to build the model. If I'm going to call rf dot score, right? If I'm going to call rf dot score, and if I'm going to pass x test data, right, comma y test data, is this a correct approach or it's an incorrect approach? Means again, I can try to like execute it, right? Now the feature must, so here it is giving you number of feature of the model must match in the input model n feature. Why this is the case? Because we have trained this random forest based on how many features? 2 features, right? And this is the original data which we have passed where? Inside KNN and inside the SVC. So if I have to find out the actual score, what I'm supposed to do? So can I say that I'm supposed to pass this data? So if I have to do a prediction, let's suppose I'm asking you, stacking you have done, right? Now give me a prediction. So how you will be able to do a prediction? So can I say that first of all, you will try to pass your data, right, inside KNN SVC, then combine it, right? And then you will try to pass that data into random forest. You will build a input for a random forest, which is the third one. And then you will be able to get the prediction. Can I say that this is the approach that we are supposed to follow? That's the reason. So we are getting this number of features is equal to 2, and you have given a wrong input feature. Yeah. So in a pipeline. So let's suppose I'm trying to do a prediction. So we have 3 model. We have basically like a KNN, we have SVC in a stack, right? And we have a random forest. Fine. So if I have to do a prediction, what I will do? So first of all, I will try to pass my data into KNN. So what I will do over here, so maybe I can write like a KNN dot predict, right? I can try to give an input. So here X test I can try to give, and it is going to give you some output. So KNN output. KNN output is equals to this one. Then I can try to write SVC and underscore output is equals to SVC dot predict, and same data X underscore test I can try to pass over here. Now these 2 outputs, can I consider this as a final outcome? This as a final prediction? No, right? We have a stacking. Yes. So can I say that these 2 output I'm supposed to combine same way that we have done at the time of training purpose, right? So what I can do, so numpy dot, maybe we can try to call numpy dot column stack. We can try to create over here, and then we can try to pass these 2 data sets. So inside this numpy dot this stack, and then we can try to pass basically KNN output comma SVC SVC output, SVC output, right? So this is the stack that we are able to create. Yes. So output underscore stack one. From stack one, I'm able to get the output. Now what I will do, so maybe I can try to like give this as an input inside the random forest. So can I say random forest dot predict? Now when we are going to give this output stack one, this is the actual prediction. Yeah, this is the actual prediction that I was expecting. Now if I have to find out the score, so what I can do, random forest and then a score, and then my X data will be this one. Output of stack one will be my X, and then what will be my Y data? So my Y test will be my Y data. So what is the accuracy? Accuracy is equals to 55% that we are able to get. Simple, right? So this is something that we are trying to create. So here what we do is, so we never pass a data to a next stack. We are trying to pass a metadata, or we are trying to pass a derived data of a first stack into a second stack. That's the whole idea behind a stacking. So that, right? So if you will try to think about the architecture once again, so what you are trying to do, so we have model number one and we have model number two. We are able to get some output from a model number one, with prediction from model number one and model number two, and we are trying to pass that into model number three. So model number one and model number two is trying to learn a relationship between X and Y. Can I say that? X and Y, because we are trying to pass XY data over here. So it is trying to learn relationship between X and Y. Is it okay? Right? But what model number three is trying to do? So model number three is trying to learn a relationship between Y hat and Y. Can I say that? Model number three is not learning a relationship between X and Y. It is trying to learn a relationship between the prediction that you are able to get from here, model number one, and your original Y. So in this way, so stacking is again one of the very good approach, one of the very good design, you can say, where we are trying to involve a heterogeneous model. So where we are learning a relationship between X and Y, plus we are trying to learn a relationship between Y hat and Y, right? In such a way that it will try to reduce a distances between Y and Y hat. So can I say that when I'm trying to learn something in between Y and Y hat, so I'm trying to reduce, or I'm trying to come closer towards a Y. So from Y hat, I'm trying to learn a relationship, that what is the relationship between this Y hat and the Y. So how to build a better model, or how to do these things in a much better way. This is something that we are trying to learn over here. So this is something which happens in case of a stacking. So it's just a design. So I can try to create a stack of 10 layer, 20 layer, 50 layer, just depends upon me, just depends upon my data division, and it just depends upon my hierarchy that I'm going to create. And in this way, even till 10 stack, 20 stack, I will be able to build the model. But you haven't used test value, you used only a validation test, is it? I believe I have used everything. And it is highly confusing. No, it is not highly confusing. If I'll try to explain in a single line. So we are taking two models, passing the data set, and then after passing a data set, we are doing a prediction. That prediction result we are trying to combine, and we are sending it to the third model. It will be used in industry. Yes, that's the reason. So we are trying to discuss, right? So just do one thing, guys. It's not confusing. Let me yeah, I told you in the beginning, right? It confuses because we are doing this train test split and all those things. So it confuses over there. Agree with it, right? Even I got confused when I was trying to go through this stacking algorithm for the first time. Spend some time. Let's have a discussion in next class. Once again, we'll do a revision, right? I'll try to type a code once again, and then I'll try to show you. But before that, try to look into this one, the approach which we have already defined and the class which we have already taken. How many of you are able to understand it? I do. Yeah. See, most of you will be able to understand. Those who are facing an issue, so it's not that tough. So it's actually simple for a second label, third label. So we are trying to use a metadata. So in this way, we can try to derive even a 10 number of stacks. That is completely fine. So fine, guys. Just try to revise. I think today we have seen three algorithm, right? So we have seen KNN, we have seen SVC, SVR, and we have seen stacking. Yeah. So in next class, hopefully I'm going to talk about XGBoost in detail, very detailed. We will try to spend a very good amount of time with XGBoost implementation, because number of parameter in XGBoost is very high, right? And it's important as well. So we'll try to invest that much of time. And then I believe naive bias is left from your classification algorithm. And what is left from classification? Yeah, naive bias is the only algorithm which is left. Yeah, from classification. And yeah, adapt, boost, and all those things will come under boosting itself. So when I'm talking about like a boosting, yeah, step one, take a data split. Yes, Dipendra, you are correct. So let me ping these things to everyone. Yeah, CAD boost, XGBoost, all those boostings will be covered all together. So I think by Saturday, then by Sunday, I'll try to cover naive bias theory plus all the, yeah, next Saturday, plan will be to cover XGBoost if time allows. Then in that case, we can try to cover naive bias theory, at least, theoretical part at least. And what we can cover, so we can try to cover then clustering we'll try to cover. Yeah, so three clustering algorithm we have to discuss. One is the k-mean, then HC clustering, and then our DBS scan. DBS scan is a very important one. And then we'll have to cover PCA. And I think after that we can start project. Yeah, so soon we are going to start project. So maybe next week I can try, but I don't think that I will be able to complete. So maybe after that I can try to start project. Time series analysis I'll complete after completing one project, because I would like to discuss one project which will be based on the entire regression, classification, and clustering, all three things, right, in a very like a deep way. And then maybe we can try to talk about a time series, and then again a project. One request from my side is just wanted to see a previous task. You have given task which you created a model where user can upload a data set and done EDA automatically. I'm not able to do that. So show that code and explain once. Which one? Which task? I'm not able to recall it, Dipendra. Which task you are talking about? EDA, yeah, I have given many tasks actually. So I gave you multiple tasks. Deep learning and computer vision कब start होगा? जब ये खत्म होगा तब start होगा. Who will take deep learning? Sunny Chandra. Yeah, hopefully he will take a couple of classes. Even I'll take, because research paper generally I used to discuss from NLP or maybe from your vision part, right? So it's me who discuss these things. Even Sunny is very good. So like yeah. So everything apart, you made ML easy. Yeah, things are actually easy. It looks difficult, but actually it's easy. Yes. Never attended Sunny's class. He is very good actually. He's sometimes I feel like he's having much more knowledge than me, right, as compared to me. So he's very good. आज का assignment बता दो. Okay, yeah, assignment, right? So you can do one thing. Or shall I give you assignment next week? You can maybe, okay, no, I'll give you assignment. Just take this one. I have filtered one data for all of you. So where is the data? Yeah. So this is a data, right? 75,000 number of instances which is given to you. So I have actually, like, I was thinking of giving you multiple pipelining tasks, but leave it. It's fine. Just for next week. So just do these things. So take this data, try to understand this entire data set. This is related to a classification problem. Again, labels and everything is given to you, right? What you are supposed to do is, so logistic regression, SVC, KNN, and yeah, so decision tree, stacking, and bagging. So with respect to this data set, right, try to build a model with a proper EDA, proper pipelining, proper missing value handling, proper data derivations, and each and everything, right? So 1, 2, 3, 4, 5, 6. So 6 model implementations you are supposed to do, a model fine tuning you are supposed to do, each and every parameter inside a model you are supposed to utilize, right? For each and every parameter, what is a value you have taken, why you have taken that value, you have to mention those things for every parameter in every model that we have discussed, right? Even a single parameter, you have to utilize it. It's not like just pass the data and then done with the model building. No, this is not an approach you are supposed to follow over here. An approach that you are supposed to follow over there is use each and every parameter given inside a model, right? So, and that too with respect to a class and objects. So everything you are supposed to write with respect to class and object for all of this 6, right? Give a detailed descriptions and explanation of each and every model parameter that you are going to use, and then build a model, right? Build a model, build a physical file of the model, and then deploy. All 4 parameters in all the 4 places. This is a task. Simple, right? Yes. So this dataset link will be available inside your notebook, as well as I'm going to ping you this dataset now. So this is your notebook for today, right? This is your notebook, and let me download these things. So KNN we have discussed in this notebook, SVC we have discussed in this notebook, and stacking we have discussed in this notebook. Fine. So I've just renamed it, and yeah, so this is the data set I have already mentioned. Task, I have already explained it to you. So try to understand a data set as much as possible. And yes, you have to use a database to store a final result. You can use MongoDB, you can use Cassandra. I don't have any kind of a issue. You can use even a SQL. Even I don't have an issue, but you have to use all the coding standards. That is a first requirement. The very second requirement that I have over here is that deployment link I'm expecting, along with a detailed coding explanation. Is it fine to all of you? Fine, right? To all of you? Yes. Deploy final best model. So yes. So here you are multi-class classification. So you are supposed to define why, like you are, what is the accuracy, what is the precision, what is the F1 score, what is a recall, how you are selecting a model, how you are selecting a threshold value, ROC, AUC curve, each and everything I'm expecting over here, right? So ROC, AUC curve comparison, a best possible model that you are trying to create, right? How you are doing a selection of the best possible model, how you are trying to make sure that your model is not a overfitted model, right? So each and everything you are supposed to clarify in your complete notebook or whatever you are going to prepare. It's up to you, right? But you are supposed to give a justification. You should not just like send a data and then give it to me that, okay, my model is done. No, that kind of a solutions we are not going to accept. for this particular task. So each and everything you are supposed to check. If it is an overfitted model, then what you have done to handle that model. If there are some classes which is available, maybe in a which is having a less number of instances, so what you have done to handle those kind of things. So everything you have to define, and then you have to submit your solution. So best model finding approach, you are supposed to define, means everything simple: ROC, AUC, F1 score, precision, recall, right? Confusion matrices for all the multi-class classification, because there are so many classes over there. Yes. And deadline for your submission is before next Saturday, so that by Saturday, Sunday, I will check your solution, and then maybe by Monday, so we can schedule a open discussion. So where a person who is going to prepare this entire things, their approach. So see why I'm giving you this unknown kind of a data set. The reason behind giving you this unknown kind of a data set or random data set over here is very simple. So that you will be able to use your brain, that okay, this things we can try to use, and maybe this is the result which I will be able to access, right? So can you open a data set, download it? I already have the data set in my system. So not this one. So yeah, this was another problem statement I was like trying to give you, but as of now, this is fine. So this is another data set I have downloaded. I thought of like giving you one problem statement based out of this data set. Again, here there is like so many records, 71,000 records are there, but still it's fine. Leave it. I'll give you next class. As of now, just try to like do these things with this one. Yeah. So I have a problem with connecting UI with my notebook, given that data set. I'm like, what, Kunal? I'm not able to understand. Problem connecting UI with my notebook. No, Kunal, I'm not able to understand your problem. So if you can reiterate. Okay, so okay, yeah, what I was saying is like try to understand this entire files, try to decode this data, and then try to perform this operation. Okay. I think now I'm not in mute. I think I'm audible, right? Okay, you said that justification of parameter. What was the question? When you say justification for the parameter, what do you mean by that? That optimal parameter get decided by the grid search. Yeah, justification of this parameter means what is your understanding about this parameter? Why you have even considered this parameter? I'm not talking about the parameter value. So I'm aware about this fact that you are going to find out that parameter value by grid search. Everyone can understand that part. I created a model, I have a prop file, all things, also created a UI, but not getting any output when running in that PyCharm. Try to debug it then. So if there is a code, so it is supposed to run, it is supposed to like execute, otherwise come to a doubt clean session. Clarify your doubt over there. There will be a people who can resolve your concerns, who can look into your system, right? When we will start to end project with ops stack. see, for everything, don't ask a timeline, right? It's not possible to give a timeline. You are learning something, you will be able to use these things. That is very, very important, not your timeline. So, okay, can we use stacking on a small data set? Yeah, but again, small means what? So, what is the definition of a small? You can't like it's just a comparative things, right? So, fine, guys. With that, thank you so much, and see you again in my next class, Saturday. Yeah. So, hope you all are able to learn something today. Plus, you are able to understand the task, right? So, just to start working on the task part, and yeah, so soon we are going to discuss a project. So I think we have already discussed about that, right? By the way, best wishes for Durga Puja. Thank you so much, and you too, Arnav. Thanks, everyone.